be posted, and the presentation will be posted to Cascade's IRP website. If you haven't had an opportunity, go check that out. We have also posted a feedback report. So we have gotten feedback pre and post IRP tag meetings, and we are putting our responses in there. That way everyone knows some of the discussions that aren't taking place during the tag meetings. That way it's very transparent and everyone knows what's going on. So we'll get going. I'll start out with the agenda. We'll do introductions here in a bit. We'll do a quick safety moment. We'll talk about public outreach, stakeholder engagement. Then we'll go into demand forecast with Ashton, customer forecast, forecast results, and then I'll touch a little bit on the climate change impacts in the non-core outlook, and then Devin will wrap us up with market outlook and long-range price forecast. Are there any questions before we do introductions? Any comments? All right, so I will go through the list here that I have, and I know that we have at least one person who's new to this, to our tag process. So please make sure to introduce yourself, let us know your position and the company you are representing. I'll go first. I'm Brian Robertson, Supervisor of Resource Planning with Cascade. Abe Abdallah.
Yeah, Abe Abdallah, Senior Utility Analyst with the Public Utility Commission of Oregon.
Thanks, Abe. Pam Archer.
Yeah, Pam Archer, Cascade, Regulatory Analyst.
Thanks, Pam. Bruce Folsom.
Good morning, Bruce Folsom, IRP Consultant, independent under a company of my own name.
Thanks, Bruce. Kathleen.
Hi there, I'm Kathleen Campbell. I'm with Engineering Services.
Thanks, Kathleen. Corey Dahl.
Yeah, I'm Corey, and I'm an analyst with the Public Counsel Unit of the Washington State Attorney General's Office.
Thanks, Corey. Monica Kalashaw.
Good morning, Monica Kalashaw. I manage Cascade's Energy Efficiency and Community Outreach Program.
Thanks, Monica. Brian Cunnington.
Yes, this is Brian Cunnington with Cascade Natural Gas. I am Manager of Industrial Services for Eastern Washington and Oregon.
Thanks, Brian. Ashton Davis.
Hey, Brian. This is Ashton. I am an economist with Cascade, and I'll be presenting the demand forecast.
Thanks, Ashton. Byron.
Hello, my name is Byron Harmon. I'm a regulatory analyst with the UTC.
Thanks, Byron. Kim. Kim Herb. If you're there. No problem. Kim is with OPUC. Oh.
Sorry, I was having trouble unmuting.
No problem.
Thanks for covering me, Brian. Yeah, so I'm Kim Herb. I'm the Utility Strategy and Planning Manager at the Oregon Public Utility Commission.
All right, thank you, Kim. Becky. Becky Hodges.
Sorry about that. Pam had to remind me to unmute myself between my headset and my computer. I do budget and forecasting and analysis with Cascade.
Thank you, Becky. Kathy Moyd.
Kathy Moyd. I'm monitoring for the League of Women Voters of Oregon.
Thank you, Kathy. Devin.
Hey, good morning, everybody. Devin McGreal, Senior Economist with Cascade Natural Gas.
Taylor.
Good morning, everyone. I'm Taylor Mead, and I'm a support specialist for Cascade.
Thanks, Taylor. Jocelyn.
Good morning. I am also a support specialist for Cascade Natural Gas Corporation.
Thank you. Isaac.
Isaac Myram, Regulatory Affairs, Cascade.
Thank you. Mike Parvinen.
Mike Parvinen, also with Regulatory Affairs, Cascade.
Andrew Rector.
Yo, Andrew Rector. What is my job? Regulatory analyst at Washington UTC.
Thank you, Andrew. Caleb.
I'm an economic analyst with Cascade.
Thank you, Caleb. Chris Robin.
Good morning. I'm in the gas supply and gas control groups.
Thanks, Chris. Marty Saldivar.
Hi, I'm Marty Saldivar with Northwest Pipelines Commercial Services based out of Redmond, Washington.
Thanks, Marty. Mark Sellerswan.
Gotta find that on mute.
Mark, I think you muted yourself.
Try that again. Mark Sellers, Manager Supply Resource Planning with Cascade.
Thanks, Mark. Matt Steele.
Hi, Matt Steele. I'm a climate policy analyst with the Oregon DEQ.
Thanks, Matt. Carolyn Stone.
Carolyn Stone, I'm a gas supply analyst with gas supply at Cascade Natural Gas. Thank you.
Thanks, Carolyn. John Storbeck.
Good morning. I'm an energy efficiency analyst with Cascade Natural Gas.
Thanks, John. Sudeshna.
Good morning. This is Sudeshna Pal. I'm an economist with Oregon Citizens Utility Board.
Thanks, Sudeshna. Eric Wood.
Good morning. This is Eric Wood, gas supply supervisor at Cascade.
And I think I saw Tom Party. You jumped in.
Hi, good morning, all. Tom Purdy. I manage the Vista Natural Gas IRP.
Great, thank you. And is there anyone else that joined that I missed? All right. Thanks, everyone. So we'll move on to the safety moment. It is starting to warm up finally outside. So I know everyone's going to start going out, enjoying the outdoors. I want to make sure everyone enjoys the outdoors safely. So while you're hunting, fishing, camping, enjoying any of those activities, make sure you apply to all the hunting, fishing laws. Make sure you watch your footing while traversing through rough terrain. If you're out hiking, make sure you avoid sprints and strains. Make sure campfires are fully extinguished before leaving campsites. Wear sunscreen to make sure you protect your skin from any sunburns. Protect yourself from insect bites, stings by using any sort of repellent or incense. And then make sure you drive safely on the roads, especially if you're doing any off-roads with ATVs, UTVs. And also make sure that you stay hydrated while you're out in the sun. If you're out in the sun for a few hours, make sure you drink a lot of water to stay hydrated. All right, so we'll jump into our public outreach plan. We had a request to go over our public outreach plan, what we plan to do to reach more of the public for our tag meetings, to try and get them involved in the IRP process. We kind of identified 5 general segments of stakeholders: commission staff, customer representatives, community-based organizations, expert public, and then general public. We kind of identify those as 5 different stakeholders. If you think there's anything that we're missing there, please let us know. Cascade notifies, we plan to notify these segments in several ways. We're looking into bill inserts, like we mentioned before. Those are the most expensive option. So we're going to try these other routes, but we're also not saying no to bill inserts right now. We do plan to do media releases to broadcast and print outlets. We'll continue to do social media, so Facebook and Twitter posts. And then once we do in-person meetings again, we'll continue to do the one meeting in an area of our service territory to try and get some of our customers to show up. And then obviously we have our webpage. We've tried to make it easily findable on our website. And then there's a lot of information, ways to contact us. You can watch old tag presentations. There's tag minutes if you don't have the time to watch the whole video. And then there's the presentation itself, as long as the feedback report. And then we also have the commission web pages as well. So like I mentioned, we have our dedicated internet web page. If you don't have that link or you can't find it, please let me know, and I will provide that link to you. And Cascade does feel like we have put forth a good effort to notify participants of our tag meetings. We plan to continue to notify participants and improve notifying people, try and get more involvement into our IRP process. I also want to give a shout out to Monica for providing information at the Conservation Advisory Group. She's done a great job informing that group of our IRP process and that timeline. And stakeholder engagement, we just...
Hey, Brian, this is Bruce, if I may.
Yes.
I have a question for the WTC staff. I believe that on April 21st, the commission held a public workshop to go over performance measures. And Brian, go back to slide 4, please.
Yeah.
So my question to the staff is those 5 different target markets. Do you have an idea of any breakdown of this, particularly the general public? Do you have any idea how many general public type people came, or was this basically the first 4 categories? And this is just for us to kind of learn maybe some of the things that you've done that might work for us.
Hey, Bruce, it's Andrew Rector. No, I do not know. Yeah, I'm not sure. What day was it? Did you say April 21st?
Yeah, April 21st. There was a blurb in the Spokane newspaper basically saying, y'all come, and I did not participate, but I was just kind of curious if the general public, is engaged. Soccer moms, soccer dads, retirees who want to recreate. I'm just kind of curious how that works, because we're trying to drive participation. And we've got some anecdotes, but that would not be a good use of our time now. But I'm just kind of curious what you guys have learned and what we could be doing.
Yeah, I would have to look into that. I don't have that specific workshop on my calendar at all, on my personal calendar. So I'm not sure which one you're really talking about. I would have to go just kind of fish around and see what people can tell me. But yeah, I don't really have any of that information off the top of my head here.
Okay, thank you.
I was actually going to ask Brian, do you do kind of one-to-one outreach to any of these groups? I'm thinking specifically community-based organizations, to just kind of invite those folks to try and get participation from them.
That's something that we're looking into. I've been trying to compile a list for that. So it's not something that we've done yet, but we plan on doing. I did reach out to the docket, the UM 2178 docket list of participants, and asked if anyone from there wanted to be included in our IRP process. And that actually got quite a few people. I think there's several on here that were from that docket. So we have done that. One thing I'm looking into, as we mentioned up here, is the community-based organizations.
Okay, got it.
Yep. Kathy, do you have a question?
Yeah, I was just wondering if you have any way of monitoring your website to see what types of people are accessing the website information. Although I must admit that I have a tendency to keep windows open and keep going back and to the website and getting the presentations and things.
That's a good question. I actually don't know the answer to that, but I'll reach out to our IT group and see if there's a way to monitor the number of views to that site. It looks like we had some people raise their hands. I don't know if anyone wanted to touch on this.
This is Monica. I was just going to mention that our customer communications folks, Byron, is able to pull Google Analytics that shows like which email, or not email, excuse me, which websites drive customers to our different website and different aspects of the traffic. So I'm sure that would give us a little bit of insights into that, Brian.
Oh, awesome. Okay. Yeah, I'll definitely look into that. I communicate with Byron quite a bit when we need our IRP website updated. So yeah, I'll talk with Byron and
yeah, I asked him for some Google Analytics on that. Thank you.
Yeah, thank you.
Byron from the UTC here, about outreach and stuff like that. I reviewed your outreach plan from the first IRP, the stakeholder engagement plan. And I kind of drafted some sort of like informal comments that I'd like to, maybe if you have some time, talk informally about. It might be kind of a long conversation, so I wouldn't want to eat up everyone's time in this forum with that conversation.
Definitely. Yeah, we can definitely set something up for after tag 2, and I'll try and summarize that in our feedback report that's out on the website. All right, any other questions? Okay, I'm just going to touch on the stakeholder engagement. This is, we provided the stakeholder engagement document out on our website as well. For attendance at meetings, in an effort to further clarify roles and responsibilities for a company as well as stakeholders, Cascade follows a stakeholder engagement design document, which was presented at Tag 1 and it's posted out on our website. In past decades, rules of the road for participation in Pacific Northwest utility advisory groups and collaboratives have ranged from fully informality to specific charters. The latter has taken significant time for crafting and agreement by all parties. Our design document attempts to capture this from the best approach. Something else I want to touch on is our meetings are pretty informal. You can interrupt us throughout the presentation, raise your hand, just unmute and chat. Whenever you have a question, just let us know. With that said, we'll move to the demand forecast. Before that, are there any questions?
I have one. Oh, go ahead.
You go first.
Okay, I was going to ask, Brian, I don't know if you mentioned this, are we going to do a break after my section or in the middle, or when do you want to do that?
Yeah, we'll try and do a break. If we can try and find a natural spot to break around 10 o'clock, let's do that.
Yeah, I think mine will only last till It's usually about 30 minutes, so that should work out really well.
Okay.
So I took a chance to look at your presentation yesterday and earlier today, and I've kind of come up with a lot of questions about it. I don't want to waste everyone's time during your presentation. Would it be possible to address my questions at the end so I don't like bog everyone down in very technical questions?
Yes, so at the end of the meeting, we'll have some of the IRP folks stand by and you can ask questions. If it's going to take too long, we may have to set up another call. I know other people have some other responsibilities after this meeting, so but we'll definitely answer any questions you have, and if we need to set up another meeting, we can.
Great.
Yep. And hopefully we can answer some of those. I'll try to get pretty technical here in this part, so hopefully we can answer some of them, but we'll see. I'm going to go ahead and request control, Brian. Let me know if you get that.
Okay, you should have control.
Cool. I see my little face around the screen. Where's the arrow? There it is. Okay, so here is the this is our service territory. This shows, I have another map that's a little bit cleaner here in a few slides, but we wanted to show the map of Washington, Oregon that shows our service territory and all the city names and just real detailed. I do have a cleaner one when we start talking about weather zones in a few slides. But yeah, we operate at Washington, Oregon. You can see central, eastern Oregon, and then southeastern Washington, central Washington, and up in the northwest corner. Oh, I can use the arrow keys. Cool. Okay. So this is kind of a dry topic. I know people probably be falling asleep. All I ask is that you don't snore over your mic, and I won't be offended. But I do like to start with a little bit of fun. There's this website I found, tylervigan.com. He finds seemingly unrelated topics that have a ridiculously high correlation for absolutely no reason. So this one's pretty funny. Per capita consumption of chicken apparently correlates really high with total U.S. crude oil imports. He's got a bunch on his website. They're all pretty funny. Just trying to lighten the mood before we get into some real dense technical stuff. So the demand forecast is developed for the IRP. It's a forecast of core customers. Brian will talk about non-core later. So this is focused on core. We forecast the customers and their usage. We also do a peak forecast. And then typically it's for the next 20 years. That's what the IRP is. But for this IRP, we are going out to 2050 to better align with a lot of the decarbonization planning that we're doing. So the demand forecast is forecasted at the city gate and city gate loop level. And I'll talk about what the loops are here in a little bit. I'm sure most of you are familiar with that, but we forecast down to the rate schedule and down to the daily level. So we get pretty granular here. So I'll talk about a little bit about some definitions. There won't be a test on this, so don't worry if some of this just goes right over your head. This is just some definitions I want to expose you to before I start referencing them constantly. So AIC is a statistical measure. It's kind of like a score. So if I have 6 models for one given data set, the AIC helps me determine which model is kind of the best. And AIC is really cool because it punishes highly complex models. It really likes recent data versus the older. So it has a lot of cool aspects of it that it's a really good way to kind of compare models, but you can only compare models given the exact same data set. So an AIC for Bellingham residential can't be compared to an AIC for East Stanwood commercial. You can't do that. They have to be on the same data set. And then we'll talk a little bit more about that as well. ARIMA terms, I'm sure people have heard of. This is how you take a linear model and kind of transform it into a time series model. You're kind of adding time as an aspect of the model. When we always start with all of our, just as a preface, we always start with a linear model, and we only get more complex if the tests that we run determine we need to get more complex. We're not trying to just throw in the most complex regression model possible right off the start. And so when you do a linear model and you start with it, it will pop out what's called errors or residuals. These are what the linear model determines to be just random noise. It doesn't think it's useful in predicting. What we do is we can run like the Durbin-Watson test. There's quite a few tests we could run. We essentially look at those residuals and we look for structure or patterns. Because if there's structure or patterns, that means it's not random noise, and there could be more predictability in the model or in the data. So that's when we start getting more complex. We add ARIMA terms or Fourier terms, which I'll talk about here in the next bullet point. Fourier terms, I won't read through that ridiculously complex math definition, but essentially these help me find seasonalities within a time series data that I wasn't able to capture with regressors. It's kind of like my catch-all. You might hear other people refer to them as seasonal dummy variables. They're kind of interchangeable. Fourier terms just kind of help speed that up when I'm looking for those seasonal dummy variables. You'll only typically have, usually I think my models only go up to 3 different terms for Fourier, so not very many. And I have some graphs here in a few slides that'll show like the effect that those terms have on a forecast. So it's a little more clear rather than just shouting random words. You can actually see it visually. Weather's defined, of course, HDDs, referencing 60 degrees. Wind is just the average daily wind speed. And then city gate loops, I had referred to earlier, that's when you might have one customer that could get their gas from 4 or 5 different city gates because they're all connected. So we forecast them as a group, or a loop is what we call it, rather than trying to deal with all that overlapping, what therm came from what city gate. So that can be an easier way to deal with that. And we have, off the top of my head, like 7 or 8 or 9 loops somewhere in there. So what do we do our demand forecast on? Like, what software do we use? We use R. My background is in R. R is a free statistical computing software environment. Anybody can download it. It's completely open source. I really like R. It has thousands of packages. These are like pre-bundled, packs of code or data that can speed up some of the code writing that I have to do. So if that screenshot on the right is not necessarily meant to be like legible. I know it's kind of tiny text, but it's just kind of a brief look at, it's not just a button that we hit to run a demand forecast. We have to import all the data and clean it and check it and write all this code. And the packages come in handy. Like if I have a linear model and I want to add an ARIMA term to it or run the Durbin-Watson test or something, I don't have to research, the mathematical components of how to implement ARIMA. I can just download the forecast package, and that has the ARIMA command in it. So that's how I save time through the packages. And then lastly, R is really, really fast compared to like Excel or our old modeling software, Sendout. R can do, I think on our weather thing, we do 70 or 80,000 Monte Carlo simulations. Our old Sendout could only do 200 it would take the entire weekend. Sometimes we'd come in on a Saturday and check it. Excel is going to crash once you get above a certain file size, at least for us. And then R, I can do 70 or 80,000 simulations, and it takes 20, 30 minutes tops. So it kind of depends on what I'm doing, how many R I have open, stuff like that. So really big fan of R. It can really calculate a lot of those complex calculations pretty fast comparably to what I've seen in the past, at least. So I can go to the next slide. There we go. So here's a cleaner. This is a cleaner map from the first map that we saw. This shows the 7, but this focuses on the weather locations that we use. So every city gate, every customer, every city gate loop, they're all going to be assigned to a weather station, and then they will inherit the weather data from those weather stations. So the HDDs and the wind will be assigned to them based on the weather station. We have 4 in Washington and 3 in Oregon. See Bellingham, Bremerton, Yakima, Walla Walla, and then Pendleton, Baker City, and Redmond for Oregon. So here is just a quick, where are we at? Kind of historically looking at the end of 2021, We have on the left, you'll see core customers by state. So we're about 26% are Oregon, 74 are Washington. The usage or the load is also that down to like maybe a couple decimals off is the exact same. The Oregon load is about 26%. Washington about 74%. I didn't want to throw an identical pie graph on there just to take up space. So that middle graph there is the core customers by class. You'll see that industrial is only about 1/4%. Commercial is around 12%, and residential is just under 88%. But if we look at those, the usage by class on the right side, you're going to see slightly interesting. Well, I guess you could assume that would be the case. The industrial only takes up 1/4% of our customers, but they take up 7% of our load. They use a lot. Commercial is very similar, 12% of our customer base, but they take up 40% of our usage. And then I guess I didn't line those colors up correctly. I apologize about that. And then the residential is 53% of our load, just over half our load, but they take up 88% of the customer base. So you'll see the usage, of course, presumably it differs among them, and that just kind of accentuates that. So that's just a brief overlook of kind of where we're at the end of 2021, and then we'll start getting into the methodology for the demand forecast. If I can get it to go to the next slide. There we go. All right, so this would be the overall process. I am going to dive into each section here so that the input data on the left, the customer forecast on top, the use per customer on bottom, and then the inevitable multiplication of those models to get demand. I'll dive into each one of those, so don't feel like you have to jump in and freak out if I move on to the next slide. I'll dive into each one of these, but this is kind of the overall, just the overall map of how the whole thing looks. So if we zoom in on the input side, that left side, we have historical load or actual flow, whatever terminology you want to use. That's going to come from pipeline actuals and ThoughtSpot data. Now, pipeline actuals is data from our, the gas software systems that gas supply has that tells me what actually flowed through each city gate, and it's on a daily level, which is great. But it doesn't tell me what rate class it flowed to, and so that's where ThoughtSpot comes in. ThoughtSpot is kind of where a lot of the billing data is stored for us, and so that will tell me every rate class, commercial, residential, industrial. It'll tell me what the usage went to, but it's monthly. And so we kind of use and I'll talk about that here in a few slides. We kind of combine those. We use allocations from ThoughtSpot to allocate the pipeline daily actual flow to get a really accurate number down to the rate class. And then the weather comes from Schneider Electric. We've looked at NOAA in the past due to stakeholder feedback. Some of our weather zones were fine, but some of them had missing data, some even up to a month of missing data. If it was just a couple of days, I could probably just interpolate it or do some sort of mathematical estimate there. But sometimes it's up to a month. So Schneider Electric does provide like that consistent weather data, and we also get wind from them as well now. Customer count is from that ThoughtSpot, which would be that like billing system storage platform. That makes it really easy to pull that data out of ThoughtSpot. It used to be, if you've been around, it used to be CC and B. So this graphic used to have CC and B on it in the past IRPs. So that's what's changed here. Population and employment, or any other economic data that we want to investigate, really, that's going to come from Woods & Poole. It's a consultant. We get annual reports from them. But also from market intelligence, our subject matter experts. What do they know that's going on in the economy that maybe is not reflected in some of these data points? And how can we implement that? And so that process, we haven't even got to the forecasting, and this process can take, a while. This can take a few weeks to line up all the data, to make sure the data is accurate. I mean, sometimes you'll look at a number from a couple years ago and it's really, really high, like what's going on there? You have to investigate it, find out if that's real, if that's a mistake. So kind of cleaning that data can take quite a while as well. And then unifying those inputs. I mean, like I had said, pipeline actuals are daily at the city gate level, but I have no idea what rate class they go to. Woods & Poole is at the county level, so I have to assign every single city gate to its county and line that up. Luckily, that's usually kind of a one-time updating thing because you just keep that Excel file on hand. And then the thought spot is it's by city gate by rate class, but it's monthly, it's not daily. So you kind of have to unify all these inputs before you even begin the process of forecasting. Market intelligence monthly, of course, is like I had mentioned, some that we'll use. It's kind of an internal document that we have that kind of gathers our subject matter experts and tries to get their opinion or an idea of what's going on in their world, so I can kind of have a big, broad view of what's going on. And then, yeah, like I said, unifying inputs. It's a really important part of the process, and it takes a long time. It's not like back in college, I was given 5 data sets and everything was perfect. It all lined up. The challenge was the forecasting part. Well, in the real world, it's not quite as easy. So learn that the hard way, but it's definitely an important process. I am going, sometimes I get going kind of fast. If there's any questions, seriously, just turn on your mic and yell at me to stop. I don't mind at all. If not, I'll just get into the customer forecast and the use for customer forecast. So customer forecast, this is, again, we forecast by city gate by rate class. So that's going to come out, this time it comes out to 200 different models for customers, and then 200 more for use for customer. And so for the customer forecast, we regress on population, employment, and then if we need to get more complex after we run those tests, like I had mentioned, we'll do Fourier terms and ARIMA terms as well. So like I had stated, we always start with a linear model. You want to start as simple as possible. You don't want to overfit your data, and you don't want to give it the the bias that it has way too much predictive power compared to what it actually. You want to accurately measure its predictive power is essentially what I'm saying. Some models we have are naive models. What that means is it just carries the last data value forward, and that's just a couple of our industrials, the city gates that have 2 industrial customers for the past 20 years. It's just a flat line for as far back as I can see. I'm not going to try to add some sort of linear model with regressors when nothing's changing. So some of those are just simple naive models, but it's very few. And then we do test for collinearity because, and I actually found this out the hard way. I was running some regressions on population and employment together, and as you can guess, sometimes and often, population and employment both trend in the same direction. Population's increasing in a booming economy in a certain town. Maybe everyone's moving there. Well, employment might also be booming. It's not always the case, but it can be certainly the case in a lot of areas. And what you'll see is if they both provide the exact same trajectory or forecasting benefits to a model, if they're collinear, you can get some really funky forecasting results. And I had been playing around with population by itself and then employment by itself, and they were both seen as really good predictors. So I put them both in the model, and all of a sudden my forecast went straight down to the ground. And I was like, what's going on here? This doesn't make any sense. And it doesn't always happen. Sometimes they're collinear and the forecast looks fine, but sometimes it can really mess with your forecast. So I forget what the package is called in R, but there's a package that we use that has a couple tests for collinearity, and then it ranks the variables and gives them a score. And then whichever score is the lowest is the ones you want to keep, and you can remove the poorly scoring ones. And so here are some of the inputs. This also doubles as a great visual of what I meant when I talked about unifying inputs. So these are some of the inputs into the customer forecast. You'll see in the top right a little snippet of woods and pool data. So that's population and employment in thousands. That's by county and by state. Here I have Oregon in there. And then thought spot data, that's kind of that billing system. And you'll see that's monthly. Unfortunately, it's not daily, but it does have some other cool information in there. It has MR cycle, which I'll talk about. We found out recently that that's the billing cycle that the customer is on. So that's super useful. Again, I'll talk about that in another slide. It also has the rate class, that SP type, industrial, residential, commercial, or if you go over a couple columns to the left, rate, that's the important column. It shows what rate class they are. It shows the total therms they were billed and then the number of customers. So that's super nice. We develop allocations between the rate classes with that monthly data, and then we apply that to the actual daily flow, what actually flew through the city gates. We apply those allocations to the pipeline data. So if we have January 1st, 2015 for Aberdeen, we're going to find what percentage went from ThoughtSpot, what percentage went to residential, what percentage went to commercial, all those. And then we apply that to that core number there on the pipeline data. And so that's a whole R script in itself that's separate from the demand forecast, because again, you have to prep everything before you even begin the demand forecast. So it can get real timely trying to validate these Excel files, make sure they're accurate, make sure they make sense, getting all that ready can be a long process, but it pays off because then you get to the end. So this would be an example of one of the 200 customer forecasts that pop out. So you'll see that red dotted vertical line there. That is kind of where that forecast stops for this particular item. You'll see Bremerton Shelton, and it's 503, so that would be Washington residential. They're hanging out at around 35,000 customers. And if you look at the right side, we ran them through all the different models that we wanted to test, and it gave them an AIC score. And so you'll see ARIMA only with nothing else scored the worst, and then Fourier by itself scored the best. Now, the top three, they're virtually the exact same score. I wouldn't be mad if any of those were selected, but we do typically just choose the highest scoring one. I have this model table output for every single one of the 200 customer forecasts, so that there's a record of what we tested and what they scored and stuff. And just to keep in mind, you can't compare these AIC scores to a different set of data. They don't really relate. You can't compare them at all. They mean nothing to each other. So just keep that in mind. And so then we'll talk about the high and low growth customer forecast. We have a lot of other scenarios that we'll be tackling, but these are pretty easy to pump out while I'm doing the demand forecast. And then when we get into other scenarios, then we can work more on those. But these are kind of my quick baseline, like what would a high growth look like? What would a low growth look like? What we did is originally I wanted to go to each city gate and look at the historical slow year and a historical fast growing year and kind of work with those to develop a future. But the problem is that didn't really work with all of the city gates. Some of them just consistently grow at a pace. There is no slow year or fast year. Some have slow years and fast years. Those would be easy, but some don't. So I ended up aggregating the data and looking at historical growth numbers that were slow just as a whole and how that compared to the average growth, and then fast years and how that compared to the average growth. And overall, what we saw was about a high growth year is going to see 1.5 times your average growth or your expected growth. And then a low growth scenario historically looked to be about half the growth rate of the expected. So then I would apply that to each city gate and each city gate rate class. And then you get this beautiful looking graph where the high growth starts in the exact same spot. And then it slowly deviates from the expected, with the gray line being the high growth scenarios and the orange being the low growth scenarios. And it works really well. If you look at the top right, Castle Rock 504, so that would be commercial. They are just, looks like they're remaining flat, maybe slowly declining in the recent years. And the high growth scenario is still declining. It's just declining at a slower rate, which is what you want to see. I had also investigated using confidence intervals of my forecast to be the high and low growth, but those they weren't dynamic. It was a static distance from the expected for the entire forecasting period, and that just didn't seem realistic or reasonable. So real happy with these results here. They look really well. I have the system customer count in the bottom right. That's just our overall total. We're just over 300,000 customers currently. And then you'll see that the low growth almost goes flat, and then the high growth goes above and expected there. So I also have some hard numbers and percentages, I think in the next slide or maybe in a couple slides. Yeah, so I have it right here. This would be, I won't read through each and every percentage, but I'll kind of give a summary here. If you look at the top table, the yellow system table, the total number right there at the bottom of the middle base case scenario, this is, I should have labeled this is all average annual growth rate over the planning horizon. So 1.52% would be the average annual growth rate. That's got a low case and a high case there. Just for reference, the last IRP, I had predicted 1.56% growth, but it seems, due to updated recent data, we are now slowing down just a hair. Kathy, did you have a question?
Yeah, I was just wondering, the effect of legislation, for instance, building codes that say no new gas after a certain date. I would expect to see more bumps in your graphs for customers due to things like that.
Yeah, that's a really good point. So, like Bellingham has, I think it's new construction commercials are banning gas, and I got together with the team and I was like, how do we account for that? Is that a variable that we need to, an indicator variable we need to pop in or something? And so we talked to some subject matter experts, and they had explained to us that the Bellingham code, the ban is only within city limits, and so a lot of our commercial customers are outside city limits. And if for me to go in there and just, almost arbitrarily or almost guesswork, go in there and say, I think this is how much that the customer growth is going to be affected, is kind of tricky. I feel like I don't quite have enough data. What's cool about our forecast is they do take into account and give heavy favor to recent data. So if I run this exact same forecast next year, where we have a little bit more of data of what actually happened, like if people are moving to Bellingham to do business, are they just hanging out outside the city limits to continue to avoid that ban, or is that ban actually having a huge effect? I just don't know what that effect would be. So I will caveat this forecast with the explanation that this is a historical based, trend based forecast. And when we get more data on how that actually plays out, I can rerun this forecast and it can better represent that. But right now it seems a little too nebulous for me to alter it. And also keep in mind, this forecast is not necessarily like what Cascade wants to happen or something. It's just more, historically based, data driven forecast. So I hope that's not too much of a non-answer, but it is something I am aware of, and I'm actively trying to just explore ways to implement that without being too arbitrary, if that makes sense.
Okay, I expect there may be more of those in the future. So sounds like
absolutely
for right now it's lost in the noise, but may not at some point.
Exactly. So I run this annually, generally for every single IRP. Now that we're combining this one, I could wait 2 years to do another forecast, but I'm just going to do this again. It is like a month-long process, but I'll do this again next year because there's just too much going on, especially with these bans, that I need to be able to capture, recent data and what's actually happening. So no, I appreciate the feedback. Come on, there we go. Oh,
Ashton, I think there's another question.
Oh, okay. I can't see who's asking, but yeah, go ahead.
This is Abe Abdallah from Oregon Public Utility Commission. I presume that you are using percentages, annual percentages, correct?
Yes, sorry, I should have labeled that. These are average annual percentages. Yep.
Average annual. Have you tried to check against real data as years go on, and what method did you use if you did that?
Yeah, we actually I can't. Brian, you had mentioned what the last like 3 or 4 years of what the growth rates were? Do you remember off the top of your head?
Yeah, so I went in and I looked at our total system, and Ashton had mentioned his forecast was 1.56% in the last IRP. And so I pulled the last, I think it was 2 to 3 years, and looked at the growth percentage, and we were right at 1.5%.
So that's for 1 year only? 1 year you're talking about?
It was the
average for 1 year.
No, I think it was yes. So from year to year, the growth rate was 1.5%.
Yeah, it would be interesting to see if you use a least square method or something to check how good is each model compared to what actually happened.
Right.
Yeah,
So
that's a really good point. And I do talk about, I think in the last IRP, I did some cross validation, and so we did I think it's called the holdout method, where I take the same methodology for developing these models, but I stopped the data being allowed into the model in like 2017 or 2018. Just kind of pick a year there, and then I allow the model to forecast, and then I compare it to real data from 2019, 2020, however many years we have. And I graphed it, and we actually got some really good feedback from doing that. And I'll talk about that a little bit later when I talk about customer class shifting. We found out through that cross-validation that some of our billing data might need to be lagged 1 month, and I would not have been able to know that if we hadn't done some cross-validation. So I plan on doing this. This tag is more about the methodology behind everything, and then when I get to tag 3, I'm going to ask Brian for maybe a slide or two where I present some cross-validation results. So I think that's kind of what you're referring to, right, Abe?
Yes, thank you.
Yeah, so I think tag 3, I'll show some, after we nail down this methodology, and then I'll show some cross-validation results. So I appreciate it.
Thank you.
So we'll jump into the use per customer forecast. Similar structure, just slightly different execution here. This is therms by therms per customer by city gate by rate class. So this will be another 200 models. That fancy equation there is just our regressors, HDDs, weekend indicator. We have a wind value. Stakeholder feedback from the last IRP had mentioned price, and so we put price in here as well. Through my analysis, it doesn't have a huge impact on the residential. It's usually like 1,000th of a decimal place coefficient, so quite small. But it does tend to get up into the 100th decimal point for commercial, and sometimes even in the 10s decimal point for industrial. So that's kind of interesting. I'd like to explore that some more. I'm not removing it if it doesn't have a big coefficient. I am leaving it in there as an econometric variable. It's just sometimes it doesn't seem to have too much of an impact, but it kind of makes sense. Residential customers, they might see their bills change once a year through the PGA, and they're not necessarily following the daily or the monthly gas prices. So it kind of lines up with what you would assume. But again, I'd like to do some more exploratory analysis on that. Maybe residentials can have, maybe I could pull the PGA price changes and see if they react to that. Definitely some more I'd like to do, but time is a factor. So I only have so many hours in the day, but that's next on my list. Trend is in there if there's no ARIMA term, but if ARIMA is entered in, then trend has to be removed. And then 4A terms if necessary. Again, we start with the linear model, try to keep it simple. Use per customer is rarely simple, as you'll see by the graphs going forward. So I don't think any stay on linear model. I'm pretty sure all of them go past that. So we'll go here to the next slide and show a graph here. If it wants to go. There we go. So this is what an input would look like. I'm sorry, the graph will be next slide. Yeah, this is what an input would look like, but this is only one line of the Excel file. I didn't want to make this a super messy slide because some of these slides are going to get kind of messy. So I'm trying to keep it as clean as possible. So this is just a single line of a really large Excel file. This looks like it's South Hermiston. You'll have a couple columns, or however many rate classes there are, you'll have that many columns there in the beginning. This is Oregon 101 residential. There's the weekend indicator volume. There's weather HDD columns. There's wind columns for all the months, and then we have price. 4A terms and ARIMA terms aren't inputs. They're actually added on later if they need to be. And then I hid some columns like the date column and the trend column, stuff like that, just to try to keep this as clean as possible. But it's just a quick example of, a massive Excel file that would be imported into R for analysis. So this is what a use per customer forecast might look like. Keep in mind on that graph that historical use per customer, that is using actual weather. So weather can fluctuate quite a bit. Going forward, I'm using a normalized, kind of like an average weather going forward, because I'm not in the business of trying to predict weather. I'm not a meteorologist. To account, though, for not capturing those peaks, we do a peak day forecast, which I'll show and graph in a couple slides. But essentially what you see on the top is a model output. This one pretty complicated. Those AR and MA terms are just a REMA in the beginning. You have your intercepts, your weekend coefficients, you have all your HDD coefficients, all your winds coefficients, and this just looks ridiculous. You have your price. You can see here, this is residential. The price coefficient is very, very, very tiny, so very little effect. And then you can look at those S1, C1 combinations. Those are the Fourier terms. They're combinations of sine cosine to help find seasonality. And I'll talk about the Fourier terms on its own slide as well to show like why do we even have those? What benefit do they provide to the forecast? Oh, okay, so it's my next slide here. Perfect. So this would be so you look at the top, that is a residential forecast for, I think it's Acme. I have a little black bar blocking the title. I apologize. But that is residential use for customer forecast, and that's without Fourier terms. And so you'll see the valleys there aren't really being captured compared to historic, and the peaks are decent. I'm not talking about those single day peaks. We capture those in a peak day forecast, but the overall, the overall cap on there is fairly accurate. But I'm more concerned about the valleys and why aren't they being captured? And so I played around with some seasonal dummy variables, and through some research, I found Fourier terms can really help with that, and they can speed it up a little bit as far as manually doing seasonal dummy variables. So what's really cool about this is you can see adding those Fourier terms to really any model, but this specific one, it really helps capture those valleys down there in those summer months, and the peaks are being actually better captured as well. It's kind of hard to see on here, but they are being better captured. So the Fourier terms, super useful, really like them. They really help our forecast be as accurate as we can get it. There we go. So peak day, we've been talking a lot about peak day and how do we capture that. So historically, in the last IRP and everything before that, we used coldest in 30. I mean, it's the coldest day in 30 years, and we insert that into our forecast as our peak day. Now, what's tricky about that is our coldest in 30 was, and Brian, correct me if I'm wrong, I think it was 1990. And so if you look at our forecast period for this IRP, that peak day is going to fall off. We don't have that anymore. It's a different day, and that could be a big jump depending on when it is. And so we needed something a little more consistent, something that was maybe more stochastic based, something that takes into account all kinds of different weather trends that are going on rather than just pick a cold day in the past. So we did what we always do when we mention the word stochastic, and our team loves doing Monte Carlo simulations. So if you look at that real pretty graph on the top right, I think that just looks so cool. That's 10,000 Monte Carlo weather simulations on a particular weather zone. That might be the system-wide weighted one. I can't remember which one I put in there, but that's not the point. The point is just to show what 10,000 different colored lines would look like. Well, I'm sure some of the colors are the same, but it looks really cool. What we ended up doing is we found the 95th, 99th, and 100th percentile of each weather location. In each weather location, we did 10,000 simulations to get a real broad general idea of all the possibilities of that weather location. If you're unfamiliar with Monte Carlo simulations, they use historical data, so average temperatures and standard deviation and stuff like that. So they use real statistical measures of historical data, but they add in a random normal variable to multiply, kind of add some randomness to it. So really useful tool there. We looked at historical peak days every single year going back, and we saw that the 99th percentile lined up really, really well with our previous peak day values, and we were super happy with it. We had started with the 95th percentile, but that wasn't quite capturing it. So it seems that we landed on the 99th percentile. And then what we do is we take that 99th percentile, that max HDD, which would be the 9,900th draw of 10,000 simulations. We take that draw and we insert that peak day into our forecast. And so you'll see when we insert it into the forecast, it shoots up one day really, really high. And now you might be looking at this and saying, well, look at that 2016, 2017 peak. Isn't that higher than what you're forecasting? And that is only true in this instance because I'm zoomed in on one rate class, which would be Oregon. If we were to zoom out and just look at Baker as a whole, you're going to see that peak day line up much better with the past. I just didn't have that data handy, so I grabbed this one. But yeah, just for reference, the peak day forecast, if you were to zoom out like at the Baker level, lines up really, really well. So I was going to put this methodology changes in the beginning, but I realized maybe I should give people a refresher of what it looks like when we do forecasting and some of the terminology. So methodology changes from the last IRP. We added price as a regressor. Stakeholders really wanted to see that, so I was happy to throw that in and do some analysis on it. We also, I kind of alluded to this earlier, that MR cycle column in the ThoughtSpot data, that is customer class, or I'm sorry, billing cycle. Billing cycle was interesting because I didn't realize this. I guess some people it's obvious, but I just assumed billing cycle was, you know, first of the month at the end of the month or something like that, kind of the same for everybody. But I'm naive and, you know, new to the industry sort of. So apparently there are like 20 something billing cycles, or I think it's somewhere in the 20s. And billing cycles, you could get billed from the 14th of one month to the 13th of the next month. You know, there's all sorts of cycles. And what that does is that can kind of skew those total therms in that column. It might be thinking that you have a certain number of therms in January, when in reality, due to the billing cycle, that most of those actually occurred in December of the previous month. And that can affect our allocations when we start, you know, dealing with the pipeline data. So Brian and I got together and graphed all of the customer classes. I'm sorry, I keep saying customer class. All of the billing cycles, along with like pipeline data and real world data, and we saw that if you are a billing cycle of 1 through 14, we need to shift you back. All the rest can be left alone. And so we shifted those back, and we're going to be running cross. So just for reference, we did cross validation. Part of our results last IRP when we did the cross validation is we noticed some of the data was it looked like it needed to be lagged a month, but we weren't sure. And so this is a direct result of that cross validation that stakeholders wanted us to do. Is, hey, you know, visually it looks like it might need to be lagged a month, and then now that we dug into the actual data, now we see, okay, we were right. Some of the data does need to be shifted back a month to better align with when the usage actually happened, not when it was billed. I saw a hand go up. Andrew, did you have a question?
Yeah, so I guess I was just wanting to make sure of exactly what it was you were doing here. So you're lagging the data for billing cycles that, what does CA14 mean? Does that mean like it ends on the 14th day of the month?
You know, I'm not actually sure what CA14 means. Brian, do you know? Does that actually mean it's on the 14th day?
No, it just means it's the 14th billing cycle. I want to say CA04 lines up with first of month, end of month, and CA04 is usually our large volume customers. All these other ones, they don't have exact dates of when they start. There's a window of when they start, and there's a window of when the billing cycle closes. It's just whenever the meter is red, and that meter's red within a window, and that's kind of the information we get. So, for example, like CA14 could be, it could be, so let's say it's December 1st to January, or let's say December 3rd to January 2nd. So we have 29 days of December data and 2 days of January data. And what happens is it's billed under January of the next year. So what we did is we found those billing cycles that needed to be shifted back to better align the billing data with our pipeline data. So when you have
Okay.
29 or so days, we don't have the exact amount of days, so it's difficult to shift it. And then you have 2 or so days in January. So most of that data happened in December, but it's being billed as January. So we had to determine which ones were better shifted back.
And so we would go into that accounting month column and shift those back iteratively through the entire document. If it's one that needs to be shifted, you change that month back one. And then if that goes from a 1 to a 12, I also have to shift the year back one too. Essentially what we're trying to do is if the billing cycle is read on the first day, like a January, it's going to read as that was January's usage in this document. And
Yeah.
you're not going to see a big difference like December, January, February. I mean, you wouldn't really even notice too big of a difference, but it makes a huge difference in like those shoulder months where you might see a ton of usage in April for a customer or a billing cycle. I'm like, pipeline data shows it's slowing way down. What's going on? Well, it's because 29 of those days were in March, but it shows up as April usage. That's not realistic. So I guess that's kind of the overall idea behind this, is to better align it with what actually happened.
Yeah. Okay. I think that's making a little more sense. And I mean, it certainly seems like a necessary step to be taking to get that data as accurate as possible. So, okay.
And then I think I saw another hand go up. I'm not sure who it was though. Go ahead.
I think
The hand
Kim,
went down.
did you have a question, Kim? Okay.
Okay, I'll move on. Oh, and then peak day. Oh, and just for reference, I will do, when I do another cross-validation presentation, a couple slides maybe in our next tag, I'll make a note here to maybe throw in some graphs that show this shift. I probably should have done some graphs here because graphically it's much easier to understand what I mean by lagging a month. So maybe I'll throw in some graphs here in the next tag and just to hopefully clear that up a little bit. And then almost done, hang in there. Non-weather dependent demand is just a few of our industrials. They don't care what the weather is. They don't have any relation to the weather. They ramp up production based off of a certain time of the year. Our models do accurately capture this, no thanks to the monthly HDD regressors, but much more thanks to like the Fourier terms or the ARIMA terms. I can go to the next slide here, maybe. There we go. So this would be an example. I think this is honestly our only example, but I'd have to look through it. We have an industrial customer in Moxie City Gate, or behind that City Gate, where they ramp up right there in that October or that September-October timeframe, and then the rest of the year they're just back to just idling, you know. So, and it has nothing to do with weather, and so my weather monthly variables are not going to be able to capture that at all. But the Fourier terms can find that seasonality, can say, hey, there's some seasonality once a year at this particular point in time, and it doesn't really care like what the weather or what the wind is. So that's super useful. I know in the past it's been kind of a struggle to figure out how to forecast this individual customer with the same methodologies as everyone else, but now we're able to do that because it just modifies it through the Fourier terms and ARIMA terms. But that's just one. Oh, did we have a question? I see a hand raised. Kathy?
Yeah, I was just wondering, are most industrials pretty much uniform throughout the year?
Yeah. I mean, they definitely vary. I'd say industrial customers are the customer class that varies pretty much on all aspects the most, at least on my end. But yeah, I'd say this is a very unique industrial customer. Most of the others are quite stable or slightly weather related. But yeah, you're right. This one's quite unique.
Ashton,
Hey there,
you want me?
it's Kathleen. This is a hop farmer. So yeah, I'm very familiar with this one. This is a hop farmer. So this is kind of harvest. So you'll see this peaking, when their crops are ready. Mint stills will see this, hop farms, we see this seasonal load. This is probably what Brian's just gonna say.
Yes. Hi, this is Brian Cunnington with Industrial Services. Each industrial customer is really their load is going to be dependent on the raw material that comes in and also the final product that leaves. So each industry is going to have a different profile due to the economy, due to their business plan. So you're going to have food processing mainly in summer and fall. But again, I do have some food processing that's doing bottling or canning or some kind of service where they're getting it prepared for long term in the wintertime. So you've got each customer has its own portfolio. And I think what Ashton was getting at is it's not necessarily based on the weather, it's based on their business.
Yeah, exactly. Abe, did you have a question?
Yes. I would think a lot of industrials would only work during the 5 working days of the week. Would that make any difference to the forecast?
Yeah, so that was one of the drivers of adding a weekend variable to use for customers. So we do have a variable that identifies if it's a weekday or a weekend. And I don't know off the top of my head, but I would venture to agree with you, or at least guess that that coefficient is much larger on the industrial side than maybe the other rate classes. I can certainly look into that and verify that for you.
Thank you.
Yeah, and this is Kathleen, just real quick. So other seasonal ones, just so we're kind of talking, another seasonal one you'll see kind of in summer that's not during our normal demand. Peak demand, which is winter heating season, is like asphalt plants. So they look similar to this too. They'll run summer and then shut off.
Yeah, and there's a lot of variability too, like you've heard, to these industrial customers. They are the more challenging ones to forecast. I will admit that. The residentials can be quite easy. There's thousands and thousands and a nice smooth line. The industrials are a lot more variability, so those can be a pain. Kim says she can't hear anymore, so
yeah. Let's Ashton. Let's
can do a break.
Sorry,
yeah,
guys. It's not on your end. It's on my end. I think something's gone awry with my laptop. So don't worry about me. We've got Abe on the phone. I'll figure it out. Thanks, though.
Okay. I only have like 2 or 3 more slides, Brian, and then we can do a break if you want.
Okay. Yeah, that works.
Almost there. These are the results. Keep in mind that these forecast results are assuming a no climate change, like just a average, a normalized 30-year weather going forward with no climate change assumptions in there. After this, Brian's going to go through and try to kind of ask all the stakeholders for their opinion. He's going to present a bunch of different studies we've looked at and how each one of those climate change scenarios affect the forecast, and kind of poll everybody and kind of get everyone's feel on it. And once we get some feedback, we can decide on which one we like, and then I can go back to this and alter it. So this is the forecast results based off of, just 30 years normalized weather. So the last step in that graph I had shown was the customers, 200 of those models, then you have 200 use for customer models, multiply them together, and you get your demand. Pretty simple, right? So top right, you have your residential East Stanwood Loop. Those are your customer forecast. It's a residential, a lot of customers there. And then in the middle, you've got your use per customer on the exact same residential East Stanwood Loop city gate. And then down below, you'll see multiply those together and you get this load profile for residential East Stanwood Loop. Keep in mind, this doesn't have the peak day inserted. It's just kind of the baseline. Just wanted to show kind of what it looks like when you multiply all those together and you get your final product. So after everything's ran and verified, I pop out 200 graphs of the demand, 200 Excel files with all the models, and then we run through each one again and verify, make sure the results look reasonable, and go from there. So a lot of models to go through, but we make it happen. So now I'll go into kind of the overall state by state demand and then the system demand, how that compared to prior IRPs. I really like this graph because it shows the evolution of our methodologies and how we're honing in on a really solid forecasting methodology. You can see on the bottom, I have the 2016 IRP system or Oregon forecast, the 2018, both of them, both 2020s. And then the one we're looking at right now, which would be that green line on top that goes out to 2050. I also pulled some sales numbers from some accounting reports that hopefully line up with, at least give an idea of what we've seen in the past and how that lines up with what we're forecasting. Keep in mind those are on actual weathers, which can fluctuate quite a bit. Going forward is on the normalized weather because I'm not in the business of trying to predict weather. You'll see that over time, we're starting to get better and better and better at forecasting every year, especially now that we're introducing cross-validation, or last IRP we did. We're starting to continue that. It can really find any errors in assumptions or methodology problems that we have. It's just a really cool process to go through, especially with stakeholder feedback and stuff, because I don't know everything. So it really helps when somebody tells me, hey, you have a blind spot here, or you need to look into this. You can see the therms per year for Oregon is, what they're right around 90 million. If we jump into the next slide, it'll show Washington. It's going to be a little over 250 million a year. And you'll see again, same thing. Every year or every IRP cycle, we're getting better and better and better. It's lining up with what we see historically. And if we jump into the total system, just as a whole, Oregon, Washington, we're looking at just under 350 million annual therms used. You can see this one kind of washes out some of the improvements, but you still see it there. You see the slightly lower forecast in the past, and we're starting to really line up with a methodology that seems to be working. And we're going to continue to do cross-validation and keep making sure that we're honing in on a good methodology and that we're not missing anything. And of course, I'm always looking for other regressors to use, but I don't want to add regressors just for the sake of adding them. I want to make sure they're actually going to be useful. So and price does seem to be useful, more so on the industrial commercial side, but I still want to explore that some more as well. I think that Kim has a question. Go for it.
Let's see if this, can you hear me?
Yes.
Awesome. So what I had wanted to say a few slides back was first that I appreciated that the price regressor was in there, and thinking about or considering the level of granularity and the various elements or components that you have of the customers. I am curious if this is a place where we can consider such things as more demographic information or information about the housing unit in which a particular hookup is connected to. And I don't mean to bring it up here in terms of how it actually would affect demand forecasts, but in thinking about what I have in mind in particular is in trying to understand the elasticity of certain customer types. Whether there's any option to add that information in these processes to get a deeper insight about how price is affecting different customer types.
Yeah, that's super, super interesting. It's definitely something I want to look into. As always, I am limited by the data that I have available. So I might ask Brian, I think she's referring to kind of like end use, like what the therm is actually being used to power and how that responds to price. Do you know if that's data that we can investigate, or do we have that available?
It's something we could definitely look into. And one of the other balancing acts that we have to remember is currently we're forecasting at the city gate rate class level, which is 200 different forecasts. So if we start breaking those out even further into different demographics, we're starting to look at 500-600 different forecasts. Maybe there's an opportunity to roll up our forecast somewhere. Maybe we can group some city gates together. That way we can break out the demographics, but there's going to be a bit of a balancing act if we do go that route. Something that we do want to look at is the end use data a little more. We don't do end use forecasting at the moment. We just don't have that data right now in terms of the resource planning team. So that's just something that we have to keep in mind is if we try and go more granular in one area, we may have to back it off in another area. So there's going to be a little bit of a give and take just to make sure that we are able to run all the models.
Sure. Yeah.
It's definitely something we can look at.
Yeah. I mean, I know it's a challenge, and I bring it up, partly just to start a conversation about it, because I don't know, I mean, I'm interested in sort of like before one, would dive into actually getting that level of information, just sort of thinking through what we think we could learn from adding that information, and whether this would be a place to consider that kind of information. So it's more of a discussion than an explicit ask to try to dig up that information.
And if it's just to explore, if we're just trying to look at explore the relationship between end use and price, we could maybe do more of a statistical sample. Like we could try to derive what's a good representation of all of our city gates, and that way we don't have to run triple the amount of models. Perhaps I can find a small sample of the residentials, or a small sample of whatever we want to stratify those into. Instead of doing all of them, we might be able to get a little bit of useful information if we just take like a representative sample. So that might save us a little bit of time.
Yeah. Okay.
I see some other hands out there. Andrew, did you have a question?
Well, I was just going to, on kind of the point that I think that Kim just made, I was going to point out, and I think I did point this out in the chat, it seems like, and maybe I can bring Monica in here to tell me if I'm right or wrong about this, it seems like some of the data that is gathered through the conservation potential assessment process could at least be useful, or perhaps a basis upon which to do other things because it does have some of that kind of end use breakout and things like that, or at least I think it does, or maybe I'm just thinking about potential. Anyway, that was a thought.
Yeah, that's super useful information. I'm pretty sure you're right. So that's something I can work with Monica on and take a look at and see if I can get that to be if that can be useful for our analysis, and take a sample from there. And that should be, I won't say easy, but I think I have a plan going forward. So yeah.
Yeah, Ashton, this is Monica. I'd be happy to sit down with you and AEG, the vendor who developed that potential model for us, and walk through what we do have there for end use.
Awesome. Yeah, that'd be great.
And I would, if you don't mind me, I would just add that my primary interest is in, I think it is actually more in the home type and the customer income levels. So
okay.
Yeah, so not necessarily in the end use.
Gotcha.
I mean, I think in understanding sort of how those correlate and sort of what kind of behavior we're talking about. I what I have in mind more specifically is that there, I think we can assume, and we've seen some elasticity studies that suggest that different income levels will respond differently to that price signal. And understanding that is, I think, a valuable piece of information to have as you go forward and we talk about, in particular, what I have in mind, ultimately emission reductions and how you manage where the cost of that emission reduction goes. So that's what I have in mind is where the customer demographics around their income level and how that correlates with the price response.
Yeah, no, that's super useful insight. I'll see. Yeah, we'll get together and I'll just ask Monica and AEG for just all the different types of way that they are able to stratify it, and we can go from there.
Cool. Thanks.
All right. I see. Monica, did you have your hand up?
Yeah, and I think Andrew actually beat me to it with his comment. Our last Washington CPA did have an end use breakdown on the residential front by income level, which I think does speak a little bit to, yeah, Andrew wins. It does speak a little bit to what Kim's looking for. We don't have the exact same breakout for Oregon because we don't actually perform the CPA in Oregon. We can, in our discussions, Ashton, we can touch base with Energy Trust and see what they have from the Oregon side. We did do a separate analysis of our territory just based on the census data of the saturation, and that's probably not the right word to use, but percentage of overall customers in Oregon that could be eligible for our low-income program. So we might have some data that we can use, but we won't have the same level of data. So certainly we can explore that further.
Awesome, great.
Thank you.
All right, I think we have one more hand up. Kathy, did you have a question?
Yeah, I was just wondering, with this increase in customers, isn't that going to make it even more difficult for you to be in compliance with the climate protection program in Oregon? I'm not familiar enough with the Washington program to know what effect they might have, but.
So I think that's definitely a conversation that we'll be having, especially at tag 3 and tag 4. I know we're going to do some scenario modeling around customer count. We're going to take some of the scenarios that were in UM 2178 regarding customer counts and incorporate those into our IRP. But yeah, we'll definitely have to keep customer count in mind when we're looking at the decarbonization planning and modeling.
Yeah, keep in mind that the final CPP was changed significantly from the what you did your modeling on for the 2178.
Yeah. Yeah, and I think as you mentioned, some Washington rules actually dropped this morning. So we should have some more information on Washington as well as Oregon for our tag. We'll have a lot of information on our decarbonization modeling at tag 4 and tag 5.
Okay, maybe I'll reserve my questions. I had some questions on your transportation users that you're responsible for on the CPP, but don't necessarily control what they do.
Yeah. Yeah. And we'll be talking about our non-core customers in about 5 or 6 slides. So if you do have questions, we can.
Yeah, I did check. I saw that you had those. So.
Yep. Okay. Let's take a quick 5-minute break. We'll come back at 10:37 and we'll wrap this up. All right, it's 10:37, so we'll get going again. But first, I want to touch base with Abe. Were we able to answer your questions, or did you still have more questions on the slides? Okay, Abe, have you returned yet?
Yeah, I could have labeled those probably better, but hopefully we explained it to Abe well enough.
Yeah, we'll touch base with Abe again to make sure he got his questions answered. But we'll keep going. I have a little bit of a presentation on weather normals, and weather normals have a big impact on our demand forecast and climate change impacts. So here's a little bit of a historical look at our weather normals. I pulled different scenarios, different ranges we could look at for our 30-year history. So this is our previous IRP is the top one. That's what our peak day HDD was, our system-wide peak day peak HDD. It was around 55.7, and our average annual normals were 4,012. And so I pulled a new 30-year. This is what we would be using, 1992 to 2021 data. It had a peak day of 49.9 system-wide HDDs. So you could see, as Ashton mentioned earlier, the previous IRP's peak day dropped off. That's why we had come up with this new Monte Carlo simulation, try to be a little more consistent moving forward with our peak day HDD. You can see that the 20-year has the same peak HDD, mainly because that 49.9 took place between 2002 and 2021. And then 15-year, when we limit the range to 2007, it's 46.7, same with the 10-year. But you can also see the average annual HDDs were actually going up a little bit for our service territory. And then I believe we had some pretty cold years around 2008, 2009, I believe. And when those dropped off in this 10-year, we saw 38.72. So you can definitely see that we have had some warmer years in our service territory over the past 10 years compared to looking back further at those ranges. So I'm going to go into what we looked at for our climate change impacts and how we're going to, we plan to change our normals. So we utilized climate change data from the Intergovernmental Panel of Climate Change. I've provided the links for all of these if you want to go and take a look at it. And also I should have mentioned this before, these climate change impacts that we're presenting and going to suggest implementing, these are only on average annual normals. We're not going to adjust the peak day at all. I know that there are there's some fuzziness around peak day with climate change. There's some arguments that there's more volatility, so we could see a higher peak day. So we're right now we're leaving peak day, but we do want to implement an adjustment for annual climate change, our annual normals. So within the IPCC, we use the coupled model intercomparison project phase 5, and I will note that I think I incorrectly put phase 4 in there on the file I sent. This has been updated. It was the phase 5. We used the RCP 4.5 scenario. It includes 36 different models. So we chose this scenario as it best represented the Western North America emission goals, and was labeled as the most probable baseline scenario. Now, this is a slightly older model when it was run. I think it was a few years ago. So this probably wasn't taking into account the emission goals that Washington and Oregon were planning to put in. So we also modeled a more conservative, let's say that the emission goals were higher than this 4.5 was expected, which we think it will be. So we took the 18 most conservative, so the half of the different models that were more conservative with climate change, as well as what the historical has been since 1979. So I'll show, if you look over in the graph, you can see the blue. This is our normals with no climate change. So you'll see every year it's the same. Every fourth year you see a little jump. That's because we include an extra day of HEVs for peak day. So the full RCP, you can see, has a very dramatic drop off in normal temperatures. This showed about a 36% decrease in our annual HEDs, which is very aggressive. The more conservative RCP 4.5 was about 18%, and I know that kind of reflects what the other regional LDCs are showing. So that's kind of what we're leaning towards. I'd like to hear back from others. And you can also see what the historic looks like if we just kept that historic trend and use that trend. It's very similar to the conservative RCP 4.5. So I do want to open it up. Are there any thoughts on this? Cascade's leaning towards using the conservative RCP 4.5. I'll actually, before I open it up, I'll go to the next slide so you can see kind of the impact it has to actual usage. Here you see that the forecast that Ashton just showed, it jumped over 50 million decatherms by 2050. The historical, just under 50 million. The conservative is about 46 million, and then the full RCP is about 42, 43 million. So I want to open up, get some feedback. One of the other things that you have to keep in mind is this will have a very big impact on our decarbonization planning. Our one concern we have with the full RCP is if we implement the full RCP, then it doesn't actually happen. We don't realize those drops in temperatures. We may be under forecasting what we need to do for our decarbonization planning. So something to keep in mind. Cascade's leaning towards the conservative RCP 4.5, but I do want to open up and see what others think.
Hey, Brian, this is Kim.
Mm-hmm.
I just really appreciate that you picked up on that. I had similar concerns, and I think while I think it's really important to be able to model the anticipated climate change impacts, the concern that leads us down a path that assumes that other strategies to reduce emissions aren't required, is problematic. So I think at a minimum, articulating that in the IRP, and sort of taking a conservative approach, conservative maybe in air quotes, that doesn't model as rather substantial reductions, maybe it will be important to be able to see that and plan with that as a potential scenario.
Yeah, definitely. Yeah, we can definitely run these other ones as scenarios. Show those impacts. And one other thing to keep in mind, we run an IRP every 2 years, so we'll be able to take a look at these, see if there's new climate change models out there that reflect more of what's happening in Washington and Oregon. So we do update this every 2 years with the IRP. So what we plan for in 2047, 2048, it's not what is going to stay. There's going to be another 10 IRPs for that time range. And that's the end of the forecast is really what's seeing most of the impact. I don't know if there's any other thoughts, comments.
So this is Andrew. I'm probably going to have to put some thought into this before before staff gives you any kind of like good recommendation here. I'd also invite Byron to chime in if he has anything that he wants to specifically say now. But I think I want to look a little bit at the RCP scenarios and refresh my memory on those and exactly what they represent and everything before I, sort of sound off on what I personally think of what Cascade is proposing here. I am a little curious if you can maybe speak a little bit more to what you're seeing from both other LDCs as well as organizations like the Power Council and how they did their climate change scenarios and things like that. Can you speak a little bit to some of that stuff? And I know we've also got Tom Pardee on the line. I might not to put him on the spot too much, but if he has anything that he wants to chime in from Avista's perspective.
Yeah. So I want to say I'd have to go back and look. I know Northwest Natural used the IPCC data. They were able to find some more local data. We looked into that and we couldn't quite get what we needed from it. So we pulled this Western North America data. I want to say that the Northwest Power and Conservation Council, and someone can correct me if I'm wrong, but I believe they had some consultants come in and do their analysis for them. But off the top of my head, I do not recall exactly what they did. I don't know if anyone else has anything to add to that.
So Andrew, this is Tom Pardee. From our side, we're working on it. We have the same action item on our electric IRP, which we do electric and natural gas separately. So, but it'll be the same type of assumptions. We have someone that has just joined the group earlier this year. We would call a climate expert. So we'll have more. I'll have more information on it. I'm not personally working on it, but probably around August is when I'd be able to share that information. That helps.
Sure. Thanks, Tom.
Yeah.
Right. Thank you. Yeah. So if you can, please look into this and give us feedback soon. We do remember stakeholder engagement document. We do have to lock things down. We have to keep the IRP moving. We got this forecast feeds avoided cost. It feeds much of the IRP process. So we do want to lock it down as soon as we can. That way we can move forward with our IRP process. So I'm going to jump into the non-core customers and their outlook. So, and there were a few changes to this. I'll try and note where the changes were. But a little bit more of an information. We're forecasting the non-core out to 2050, similar to what we're doing on the core side for the decarbonization planning. Unlike the core, the non-core, or sometimes we refer to them as the transportation customers, they schedule and purchase their own gas. So they transport it on the upstream transportation, Northwest Pipeline, GTN. And then once it hits our city gate, they use our distribution system to receive that gas. And that's how they become our customer, just utilizing our distribution system. These transportation customers include all types of industrial customers. It includes farms that may not use much during the winter, to food manufacturings that average 800,000 therms per month throughout the year. We also serve 6 electric gen customers in Washington and 1 in Oregon. Those customers use approximately 481 million therms in 2023. So that's what they're forecasted at for 2023. Our transportation customer count increased from the previous forecast. I believe we had 234 customers in our forecast for 2023, and it actually went up to 244 customers. And we do plan on bringing on several more customers. We usually look out 5 years. We'll include some growth rates to capture anything past 5 years for customers that may jump on in the future. That's still in our planning horizon. Cascade projects the transportation customers in Washington, Oregon to consume approximately 518 million therms. So those are the non-electric gen customers. And Kathy, you have a question?
A couple of them. Am I correct that you're responsible under the climate protection program for all of these transport customers if you're the one who delivers them to the end user?
We are
in the climate protection program.
Yeah, we're in charge of most of them, but not all of them.
Yeah, is there some way of finding out approximately which ones? I'm really, interested in what's going on with the CPP. So
I want to say in Oregon, we're responsible for all of them except for the electric gen, which I believe is about 60 million therms a year.
That's correct, Brian.
Okay.
This is Devin.
Okay, that was my second question: is what electric plant and which electric utility is responsible? And they're probably going to come back to you to say, hey, you got to do something because we're under HB 2021.
Yep.
So I don't think you're off the hook.
Right. Yeah. In terms of the CPP, yeah, we're not responsible for the electric gen. But yeah, that docket.
Which utility is that? PGE or Pacific Corp?
Maybe Brian Cunningham.
This is Mark. I believe it's Pacific Core. I believe.
We need to be careful here. That plant is co-owned.
We're now revealing confidential information about customer flow, individual customer flow, and that's a bit tricky in a public environment like this.
I also need to mention that it's not one owner. There's multiple owners at that plant, so we can't say it's one utility.
Oh, okay. All right. Thank you. Guess
Yep.
I have a little bit more homework to do.
Yeah. So here's some results, just a breakdown of our non-core. Transportation customers in Washington forecasts to about 457 million therms. And all of these forecasts are for the first year of 2023. Transport customers in Oregon is about 61 million therms. Electric gen customers in total for both states is 481 million therms. And then the non-core, so all transportation, all electric gen for both states, is approximately 1 billion therms for 2023. And I believe we're responsible for, in the CPP, the 61 million therms for Oregon, and then I believe in Washington it's somewhere around 110 to 120 million therms that we're responsible for in terms of the Climate Commitment Act. Are there any questions?
This is Andrew. So I'm going to ask an ignorant question because I haven't been following the CCA rulemaking and have kind of forgotten a lot of the details of the actual bill itself. But when you say you're responsible for, I think you said 110 to 120 million therms, what do you mean exactly?
So we will have some emission targets that we have to hit, some baseline targets. And those customers' usage will be, their emissions will be what we have to plan for and what targets we have to hit. So we're responsible for their emissions and hitting the targets under the CCA.
Okay.
And
all
then,
right. That makes sense. Thanks.
Yep. And we'll definitely have more information on that in Tag 4 when we talk about decarbonization planning. All right. If there are no other questions, I'm going to kick it over to Devin, and he'll wrap up the meeting with the market outlook and long-range price forecast.
Thanks a lot, Brian. All right, I'm going to try to request control here. Let's see if this works for me now.
You should have.
Looks successful, and let's see if I can.
Yeah, there should be little arrows in the bottom. Yep. Bottom left.
Not seeing them come up for me.
Sometimes you have to click. I noticed if I clicked, they would pop up.
Okay, it looks like it switched over, so we'll give it a shot. And if not, Brian, I'll just have you help me out. So I'm going to go over our kind of long range market outlook, and also do a little bit of a deep dive, not nearly as in depth as the load forecast, because I think there's a lot more nuance into the load forecast, but we are going to do more of a deep dive into our price forecast than we've ever done. We've gotten a lot of questions about it in previous IRPs, and in the interest of transparency, we really want to talk about it a little more to the extent that we can. Obviously, there's some confidentiality issues with it, but we do want to kind of do a little bit of a deep dive and try to give a better understanding of how we do price forecasting. So we'll start with the long range market outlook, and I have to laugh at this slide, unfortunately. It really does highlight the point in time nature of our entire industry, really, in the analyses we do. So for those who pay attention to the Energy Information, EIA, Energy Information Association, I believe, they do, they produce a long-term outlook once a year. And so the one for this year was produced in March. And what I highlight on this slide, just because I think I can't help but to laugh at the world we're in now, is they project that Henry Hub prices will remain below $4 per MMBTU throughout most of their projection period. And you can see the figure we've included in there, that most of their forecasts, with the exception of that low oil and gas supply, have it below $4 per MMBTU. Well, for those who are paying attention, you probably know I checked this morning what it closed at yesterday. Henry Hub for the upcoming heating season alone is tracking around $8.50 per MMBTU. The world changed, is the long and short of it from what happened. Now, we do expect prices to eventually regress, but even that regression is showing most of that pricing around over $4. I would say as prices begin to normalize, probably around low $4 at Henry Hub in the summer and going up to close to $5 in those winter seasons. It's just right now the world is different from what we were looking at in March on a lot of that. So just once again, I want to really highlight the point in time nature of doing these kind of analyses. We do the best we can with our forecasting, but it really is more of an art than a true science. One thing we are noticing is that there is steady growth in natural gas demand, and that's once again a nationwide thing. The EIA analysis is nationwide. Specifically for electric power, there was a heavy coal to gas movement. Where that will go is still yet to be seen, but that did increase the demand for natural gas. LNG, obviously, for those paying attention, is a big driver as well for that growing demand, and that is putting some upward pressure on those Henry Hub prices, essentially a lot more than I think EIA expected at the time of this report. Okay, so how do we do our price forecast calculation? So this kind of wanted to do a little flow chart of where do we start and then how does it end up? And we'll go over each one of these kind of individual items. So we start with updating our source data, and that usually happens depending on the frequency that we are, or the intensity of the markets, anywhere from once a week to daily. We're looking at it quite in depth these days just to make sure as prices continue to fluctuate that we're accounting for that. But at the very least, we try to make sure that we're updating our price forecast once a week. And we do that for the most part by updating that source data. So in a later slide, I'll go into kind of where we get some of those source data from. We can't go into specifics about it for confidentiality reasons about how we get our pricing analyses, but we can give you a general idea of where we source that data. From there, once a year, we try to calibrate, I would say, our source weights, looking at their accuracy over time. So we kind of do a point in time analysis at usually right around the end of December, how they do at T+1 going out to, I think it's depending on how much data we have, going as far out as 7 or 8 years. Basically trying to see how accurate were you at similar cross-validation process that Ashley was talking about earlier. How accurate were you in predicting what prices would be? For this validation process, we use symmetric mean absolute percentage error, and we'll talk a little bit about that in a later slide. And that gives us those base weights. Problem with those base weights is, as we'll also talk about in a later slide, for the short term, we decided that it's far more, and this also came from conversations from various stakeholders. We all kind of generally agree that in that extreme short term, so that kind of T+1 to the end of a year, the forward markets are going to be your most accurate source, and everything else is just going to be, especially in today's world with how frequently prices vary, we want to be looking at those daily sources such as what the markets show. So we use that as 100% weight for that year one pricing. But then if we try to shift to the weights that we calculate through that error analysis, it would create a significant drop off. So we interpolate our way down over a couple of years to eventually get to what those natural weights were. Another challenge we run into is what happens when we have stale data. So Ashton talked a little bit earlier about how his model, one of the benefits of it is that it really does benefit off of more current data. You always want to have more current data when you're doing any kind of forecasting if possible. So we've added to ours a age dampening mechanism that I'll talk about in a later slide to kind of reward newer sources while still giving some credence to those older sources, because especially on the long-term side, a lot of those long-term fundamentals may still be valid, but there also may be some changes. So I'll kind of talk a little bit about that when we get to that slide. And then finally, those weights are applied to the sources we have to create one forecast for each of the basins that we purchase gas for or that we look at. And so the basins we look at, just so everybody knows, the main ones that we're going to analyze is NYMEX Henry Hub, which is, as we talked about earlier, the main industry benchmark. Sumis up near the BC-Canadian border, Alberta or ACO gas from Alberta, the Rockies, and we do run forecasts for Malin pricing, although we don't typically buy gas from Malin, but it's something we want to be aware of. It can affect pricing in other basins as well, and it's just good information for us to have and to give to our gas supply group occasionally. And we also do kind of look at uniqueness of Station 2 pricing, because that can diverge from Sumis quite a bit. It's a little further north, I believe. So we do kind of get that pricing as well.
Devin,
Yes,
did you actually skip over a slide?
I may have, and if I did, I apologize. Can you help me go back by any chance? You know what? I'm going to relinquish control. Oh, I did skip a slide. Thanks. So talking more about market intelligence, a couple of other things that we're paying attention to are coronavirus, the economy, and how does that impact natural gas. Coronavirus has been tricky. We're still, a lot of people, I think there was just, not to get political, but there was just a recent headline that the US just crossed over 1 million deaths related to coronavirus. So obviously it's still very poignant and salient. So we don't want to already try to do a retrospective on it while we may still actively be in it, but we do want to try to see if we can account for it. Kind of getting into some of the discussion that Ashton talked about earlier, there is a challenge in forecasting where we want to make sure we're capturing as much exogenous impacts such as the Bellingham bands and things like that as possible, but we also don't want to force biases into any of our models that may prove to be inaccurate. So while we're trying to keep a hold of what the impacts of coronavirus may be, and kind of factors like that will certainly affect some of our recommendations on our hedging, for instance, on the actual forecast itself, we're really trying to keep it as pure as possible. But talk about some of the economic and other variables. EIA did in their short-term energy outlook. They forecast that there's going to be a decrease in consumption in 2021 and 2022, following a decline in 2020. So consumption in 2020 was 1.9 billion cubic feet lower than the all-time high that we saw in 2019. That was a result of the economic slowdown. Presumably, a lot of that was in businesses that weren't able to operate because of the COVID pandemic and lower heating demand, because there were milder temperatures then as well. One thing that we just wanted to highlight from our FERC Form 2 and our parent company MDOR's annual report, we do imply that there was no material impact to our operations or revenues from COVID-19. But how does this price volatility impact demand? Ashton talked a little bit earlier about the fact that we are trying to include price in our forecasting, and not just our demand, but that price volatility is impacting the world, frankly. And how is it impacting worldwide demand? Well, the impact of those higher and volatile prices is leading to much bigger reductions for gas and LNG. LNG, and it's still, don't get me wrong, LNG is still a major driver, but Wood Mackenzie last week did cut their forecast for gas demand in Europe by 4% for 2022 and 5% for 2023, compared with the July 2021, which was the outlook before the winter rise in gas prices. So obviously they are still looking to pull a lot of that. LNG is still a major driver, but we are seeing with these higher prices then potentially looking at other sources as well. Asian LNG demand is expected to come in at around 270 million metric tons per annum or per year, and that's flat versus 2021, and it's down 4.5% from their prior forecast of 283. As global LNG prices begin to moderate, however, once again, that's a common theme we talked about a little bit earlier, that we are experiencing extremely high prices right now, but we do hope that there will be some kind of moderation in that. They do expect that the LNG demand, at least Asian LNG demand, may rise to 280 MMTPA by 2023. I think I saw that there's a question if this includes some of the bans of Russian gas too. That's it's a great question, and the interplay of that is extremely important, because there's kind of two major forces that I personally have seen coming out of the Russian gas bans. We're seeing a much bigger green movement in Europe as they're trying to move towards those renewables. So that on the one hand may decrease the European pull from gas and also our exports to Russia. So that's going to have a really interesting play as well. However, while a lot of Europe is trying to wean itself off of Russian gas, that does increase at least short-term demand for domestic LNG exports as well. So it's kind of coming from both sides. It's a very interesting interplay that we're continuing to closely monitor. I definitely say it's having an impact on some of the pricing that we're seeing. So that was a really good question from Andrew in chat, and I hope I answered it. And if there's any other questions, let me know. But I think, Brian, we can move on. So we already went over our process. I'm not going to go over it again. So let's talk a little bit about our sources. So our long-term planning forecast, and everybody does things a little bit differently. I know some LDCs reach out to consultants for it. Some develop it in-house. We choose to develop our forecast in-house as a blend of current market pricing along with long-term fundamental price forecasts from a variety of sources. Now, those sources include Wood Mackenzie, EIA, the Northwest Power Conservation Council, S&P Global, Intercontinental Exchange, which really helps with forwards, and other various third-party long-term price forecasts. Not going to go into, unfortunately, we can't go into exactly how much we access from each of those for confidentiality reasons. But one thing we can talk, and we'll talk a little bit about each of those sources or some of those sources, while it's not a guarantee of where the market will ultimately finish, those Henry Hub NYMEX prices are really a great indicator of the especially short-term direction of future market prices. Our basins are still pretty heavily correlated with NYMEX Henry Hub. Wood Mackenzie provides a great long-term forecast at a monthly basin level, but theirs isn't as current as the forwards. Usually they produce a forecast around every 6 months or so, and that's used to help us shape some of that. Some sources where they may only have a Henry Hub forecast, or they may only do an annual forecast. Using Wood Mackenzie's basis forecast can sometimes help shape some of the other basins who may just produce, like I said, a more generic or an annual forecast. Go to the next slide, Brian. So a little more about our sources. We do rely on EIA's forecast. However, like I said, a couple of issues with it. It's not always the most current. They really only put out an in-depth long-term forecast once a year in that long-term energy outlook. And it's also only they only provide monthly breakdowns in the short term, but for longer term, we're going to want to, they only provide annual long-term prices. So basically, we take their annual price and we kind of shape it for each month based on the Wood Mackenzie similar kind of how they curve or how they expect the prices to shape. So for instance, if the Wood Mackenzie average price is $4 and in January it's $4.40, so then we would know that January prices are 10% of that annual price. So then whatever the EIA annual price would be, we would inflate it by 10%. And if, let's say, August was 10% less, we would do 10% less of that annual price for August. So that's kind of a little bit of an idea of how that shaping happens. We do assign a weight to each source for the whole 20-year planning horizon. Actually, I think that's going up to about a 30-year planning horizon, which is wild to think about. But with a lot of this carbon compliance analysis that we have to do, it really is important to do that longer term planning, or at least try to have an idea of where that pricing may be. A lot of times data is not available going out 30 years, obviously, so sometimes we do have to do some naive assumptions, basically inflating certain forecasts, perhaps by inflation or something like that. But as much data as we can gather, we try to include it in the models. It's impossible to accurately estimate the future. That's one thing we've talked about countless times. The EIA report was a perfect example, with them saying fairly definitively that NYMEX was going to stay under $4, and that's really not looking like it's going to be the case. But for trading purposes, the most recent period has been the best indicator of the market. We do consider other factors, such as some historical constraints that we may see, which can occasionally lead to minor adjustments in the long-range forecast. We do have a mechanism talking a little bit about some of those COVID bans, or if we're seeing something regional, maybe how some of the carbon compliance obligations may impact things. We do have a mechanism in our price forecasts to make qualitative adjustments instead of just the quantitative analysis, but that's a tool we really do try to avoid using because it adds subjectivity, and that's the last thing that we want to do. But if we have something that we feel really confident about, we do have the mechanisms in place to make those qualitative adjustments if needed. Brian, go ahead to the next slide if you want. So talking about those weights. So in producing our weighting system, like I said before, we use symmetric mean absolute error, absolute percentage error of our sources going as far back as we have data, which right now is to 2010. And so the nice thing is, as we continue to produce forecasts, we're going to continue to have more data, continue to get better error calculations. Some forecasts produce daily, while others are less frequent. And then, as we said earlier, we do use that age dampening mechanism to account for some forecasts that do not have the more current information. So I think the next slide talks a little bit about that symmetric mean absolute percentage error. If you want to go ahead, Brian. Yeah, so how do we get from that error calculation to our actual weight? So symmetric mean absolute percentage error, it's the absolute value of your actuals minus your forecast divided by actuals plus forecast over 2. We then calculate the weight of the inverse of the SNAPes using each source, and then we smooth that out, using Holt-Winter smoothing. We'll talk a little bit about in some slides why we do that. The 30,000-foot overview for it is one thing we've noticed with these error terms is, let's say a given source, and I'm just going to pick one off the top of my head. So EIA just happens to be super accurate at T plus 24, just because we don't have the largest sample size, unfortunately, when we're doing these error calculations. So it just so happens by pure chance that at T plus 24, they were extremely accurate every time. But then T plus 25, they weren't as accurate. But then T plus 26, they were really accurate. And you get what I'm saying. And we'll show a slide that we actually have an example of this. We don't want to have that heavy fluctuation because realistically, such short-term variance is not going to be presumably accurate. You want to kind of smooth that out and say, okay, you have a reasonable modicum of success over that period. We want to give that to you, but without some of that lumpiness, because that can create some weird jumps in our price forecast. In terms of why we use symmetric mean absolute percentage error, Ashton actually drew up this really cool graph about some of the other metrics that we considered, and following a lot of some of the literature that we did analysis for a couple of years ago, suggested that you really want to try to use a term that's going to create the most parity between sources. And symmetric mean absolute error, as you can see, had the lowest interval, kept the sources closest to relatively the same. So that's why we elected to use that for our error calculating metric. We can go on to the next slide. So here's an example of why we do that smoothing. So in this one, source 2, as just an example, we can see at T plus 11 was not so accurate. But then at T plus 12, they had almost half of the entire weight. But then T plus 13, they went down to 33% of the weight. But then T plus 14, they went all the way up to 57%. That's probably not a reasonable assumption as to their true accuracy at figuring out that midterm period, right? So if we're looking at going at from about a year to a year and a half out, obviously they're very good. They typically tend to be near the top, if not at the top of it, but they're not going to just be at every T plus 14 the most accurate by a significant margin. So we want to end up smoothing that out. And we use that Holt-Winter smoothing technique. We use R for that, and Ashton kind of runs those calculations for us. And you'll see in the next slide what the result is of that smoothing. So you'll see that by smoothing it out, we still keep them as one of the higher ranked sources. They, I believe, in this one, they compete with source 3 as one of the higher ranked sources, which source 3 was fairly accurate over that time period as well, but they're not blowing some sources out of the water now. It makes it a lot more of a consistent weight, which is going to produce a more consistent forecast, which is ultimately what we want to see. Go to the next slide, Brian, if you want. So these weight adjustments. So initially when we did this, we just used these weights and kind of just plugged them in, and that was what we did. But we've had some good conversations with our stakeholders, and we've all kind of come to the agreement that in that year 1 period, so that T plus 1 to T12, forward pricing is really going to be so much more accurate than everything else. It comes out every day. It accounts for news such as the Russian gas bans or other exogenous factors that may happen. God forbid another pipeline explosion happens. It allows us to accurately and immediately capture that impact, while a longer term forecast might not. So for short-term forecasting, it's ideal because it reflects all of those current events. Now, long-term forecasting is more concerned about fundamental market intelligence. And so that's going to be reflected in some of our other sources who have their own econometric models to produce those forecasts. So from months T13 to T48, so essentially year 1.1 going out to year 4, we end up interpolating those weights down from 100% NYMEX, to get to each of those sources' calculated weights. And then from T49 onward, we use the age dampened, if applicable, weights of each source. If you go to the next slide, I'll show a little bit about why we do that interpolation. Andrew asked a question, has anything changed since the last IRP? The only thing that changed somewhat is we got some really good feedback from Oregon staff about the age dampening mechanism, where we didn't have the best process for allocating some of the age dampened weights. And I'll kind of get into what we do now about it. So that was a minor change. Actually, in the last IRP, I don't even think the age dampening mechanism came into play because we didn't have any sources that were old enough for it to. This year we do, so it will come into play. And I'll talk a little bit about that in a couple of slides. So here's an example of using not interpolated weights. And this was something that was very jarring for us when we kind of first did this process. Logic would dictate you would want to kind of ease into such a drop like this. Well, we weren't. And then all of a sudden we would see after year 1, I think the price forecast jumped a full $1. That doesn't make sense. That's not reasonably what's going to happen. So to go from using one source 100% and then only using it 20% and just shoot the other sources way up creates some extremely inconsistent pricing. So what we do now is we interpolate it by taking that 100% and dropping it down to 0 over the course of that time period, which is 3 years, I believe. Yeah, because it's 13 to 48. So Brian, if you want to go ahead and show the next one. This shows what the interpolation process looks like. So each month we take a little bit off of that source one, which I don't think I'm ruining any confidentiality here. By common sense dictates in this example, source one would be those forward prices. So that NYMEX market price. So we're using a little bit less of it each month and then allocating it based on their weight. So you can see they're not allocated equally. They're allocated based on what their calculated weights were from that weight calculation we talked about earlier. That's how they get their share of the incremental interpolated weights. That was a mouthful. And so that's how we slowly, and if this were to continue onward, you would see by the time we hit that year 4, that source 1 would hit 0, and the other sources would be at their their calculated weights from the forecast or from the weight process. So I think the next slide, I'll talk a little bit about that age dampening mechanism now. Yeah, so with the volatility we're seeing in markets, it really has never been more important to ensure that data is as current as possible. So stale data may be missing some key factors that imprise the price forecast. However, as I had mentioned earlier, the tricky thing with long-term forecasting is it is somewhat insulated about this because it is more about market fundamentals. So you don't want to too heavily discount some of those older sources because they may still have some strong fundamental calculations that you want to include. So basically what we decided to do is if any source is more than 11 months old, so if it's more than it's a year or further out, all of the outdated sources are decremented by the ratio of how many months old they are to the aggregate number of stale months. And then those decremented weights are added back to the sources proportionate to how current their data is. I don't remember exactly how we did it last time. I think I think they might have all been added back equally. Or they might have all been added to the forward prices, which either way was not what we wanted to do. Like I said, we had some really good conversations with the Oregon staff, and they helped key us into the fact that doing a proportional add back of the decremented weights was probably the most accurate way to do that process. If you go to the next slide, I'll talk a little bit more about what we mean with that age dampening technique. So here's an example of, so you can see source one, which in this example is the market. So we're past the point where the markets are used. Source one is at 0%. We have these three other sources. Source two shows that at this time, which may be, let's say, T plus 52. I don't remember exactly what it was, but according to our weights calculation, it normally is really accurate going out to T plus 52, or at least relatively accurate to what the other sources' error terms were. Problem is, in this situation, they are 16 months old, while the other sources, source 3 and source 4, are much less old. Source 3 is only 5 months old. Source 4 is only 2 months old. So basically what we would do in this calculation is say, okay, the oldness, or I guess the age of source 2 relative to the others, 16 versus 23 months of total staleness if we combine it. Well, source 3 is only 5 over 23. Source 4 is only 2 over 23. So when we do that calculation, all of a sudden you can see that source 2 was decremented rather significantly, because that stale data does concern us. But we still want to give it some weight, because we still do believe there's value to those fundamentals. Source 3, interestingly enough, is still the highest source because it had a much higher base accuracy before the age dampening mechanism, but it didn't receive as much of, it wasn't as much the beneficiary of the age dampening mechanism. So it was only about a little bit over 7.5% the beneficiary, while source 4, being the most current data that we would have for this calculation, would be the beneficiary of almost 12% of the decremented weight because of the age dampening mechanism. So it's not the most heavily weighted source, because in the pre-dampening it was not nearly as accurate at that time out, but we want to give more credence to the fact that it does show the most accurate data. So we really like this as a way to kind of marry that balance between short-term information and still long-term fundamentals. And Brian, you can move on. I think I might be done. Yeah, so are there any other questions about the price forecast? We're always happy to go over it. We've done deep dives or further deep dives with staff in the past. And we're always happy to continue to have those analyses. If any questions come up, or if you have any other questions, either put them in chat. You can always reach out to us. And any suggestions on how to increase the accuracy, we're always happy to listen to. It's been, price forecasting has been one of the most difficult things, in my personal opinion, just because of the crazy volatility that we're doing. The nice thing is, as a little bit of a teaser to one of the later tag meetings, the stochastic analysis that we do really helps insulate us from some of these crazy swings, and gives us the tools in our belt to be prepared to protect against these with our hedging portfolio, which to kind of brag on our hedge team, for those who have been paying attention to our hedging process, has been a phenomenal resource for our customers and ratepayers, saving, I think, and this is just kind of an off-the-cuff number based on how high prices are now, saving, I believe, in excess of $50 million to our customers and ratepayers, just by virtue of the fact that doing this price forecast, doing these analyses, have allowed us to lock in prices at such a low price that our customers are not going to be as exposed to these extreme prices. So that's something I'm really proud of. But we're going to talk about that, I think, in a little more detail when we talk about some of the stochastic analyses, and there'll be a lot of information about that in the IRP as well. Thank you.
Thanks, Devin. So I'm going to cover the remaining schedule. So next up, we'll have Tag 3 Washington on June 29th, and then a couple weeks later, we'll do Tag 3 in Oregon, July 14th. We'll cover distribution system planning. So for the Washington one, expect to see Washington plans. For the Oregon one, expect to see Oregon plans. We'll talk about alternative resources, price forecasts, avoided costs. We'll have a separate avoided costs for each state. And then we'll have a system avoided costs as well. Current supply resources, and then any transport issues. Tag 4 also split up August 10th and for Washington and September 20th for Oregon. We'll discuss carbon impacts, energy efficiency, decarbonization planning, some biogas, hydrogen information, and then any preliminary resource integration results that we have. And then tag 5 again split up September 28th for Washington, November 9th for Oregon. We'll have our final IRP results, the plan components, and then the 2 to 4 year action plan. Washington will file the draft on November 24th. Oregon will file it at the beginning of 2023 on January 5th. We'll ask for comments back from each stakeholders. We're given about a month and a half for comments. And then we'll hold a tag 6 if needed for each tag. If there's any additional questions, if there's any workshops requested, we just have a placeholder for that just in case. And then the IRP filing dates, we have Washington February 24th and Oregon is April 14th. So I see a comment. The Washington draft distribution date appears to be Thanksgiving. Okay, yeah, we'll make sure to get that out a day before, if not a couple days before. And then next slide. Are there any general questions? Thanks, Ashton. Are there any general questions? I know Byron had some technical questions that he wanted to go through. I know Ashton, myself, Devin will probably stick around. Others are free to stick around if you'd like to. But are there any other questions before we go into that? There are no questions right now. Here's our contact information. Feel free to reach out to us. We'll make sure to get a response to you as soon as possible. And so if there are no other questions and people want to drop off for the technical portion, you can. Byron, do you mind if we take a quick 5-minute break before we jump into the technical questions?
That's fine by me.
Okay. Okay, so yeah, thanks everyone. If you want to stick around for the technical questions, feel free to do so. We'll come back around 11:40 and we'll go through those. right, it's 11:40, so we'll get back to some of the questions that Byron had, and if anyone else has questions that come up, feel free to chime in. But I'll give you the floor, Byron.
Great, thank you. I guess first I want to check in. You had noted earlier that some people have some time constraints, so I just want to kind of check in on that. Make sure that we're respectful of the time constraints that you guys have on your end.
Yeah, I know we have 20 minutes of the scheduled presentation. I know I'm willing to go into the lunch hour. I assume we probably don't want to go too far into the lunch hour.
Okay.
But and there may be some questions you have that we'll need to go back and pull some of our modeling details, and if we need to do that, we may have to set up another call.
Okay. So let's jump right into it. Can we jump to slide 17?
Yeah. All right.
Okay, so I see that you have looking at your equation there, you have your alpha subset 0.
Mm-hmm.
So I guess just right off the bat, as a clarification, is that an intercept term or is that a garbage term?
Yep, intercept.
Intercept.
Okay. And so I guess the follow-up question then is, from a theoretical standpoint, what does an intercept term mean?
Essentially, it's like what's your baseline, where you starting the forecast from is, I guess, the best way I would describe it, because you can have a forecast and a trajectory, and it could start anywhere on the y-axis. So essentially, that intercept is where on the y-axis are you starting?
Right. I mean, I guess I understand what an intercept term is. I guess the thing is that you're talking about population, which is already one of the data points that you have. So it just seemed odd that it has an intercept term there. So I'm not sure exactly what that's doing for your model. So you might want to investigate the utility of that, because it might be that your intercept term is picking up, basically it might be acting as a default garbage term, picking up things that aren't in your model.
Okay, yeah, I'll look into that for sure. I didn't even think about it.
Ashton, can I interject one thing here? Correct me if I'm wrong, but are the various formulas, are they actually more of projecting customer growth and not total customers? And therefore the intercept term is basically like total customers at time period 0 or whatever. I could be wrong about that.
So the customer forecast would be the total customers by city gate by rate class at a point in time. So this would be daily, and it would be the total customers up until that point in time.
The next thing that I kind of have a question about is kind of the purpose of the model itself. So I guess getting kind of a little bit stepping back and asking, what is the data actually telling us here? When you look at population data, you're looking at population data from the past. And when you're looking at employment data, you're looking at employment data from the past. So all the data that we have is, because we're living in time flows linearly, all the data we have is in the past. So I'm kind of struggling with what population or employment data tells you that your sheer customer data, which you already have, doesn't tell you. So why aren't you, I guess the question is, put another way, why not just extrapolate from the current customer data you have and extrapolate that out? Why model it? Because typically modeling in economic fields is used to kind of substantiate like relationships and then to tease out dynamics that interplay between things. But there isn't that much interplay going on here. So I'm kind of wondering, why not just extrapolate from your current customer data?
So we do have forecasts of population and employment as well from our from our consultant. So generally, I'm trying to see if there is a relationship between, linearly speaking, you're probably right. But if population is increasing at an increasing rate or decrease, changing at a different rate, and then the forecast also shows that, it helps me determine if we can make alterations to population and employment in the future, which would then change based off of their historic relationship. So it's not, like I had said, every model doesn't necessarily, it doesn't win with population employment every time. It's just something I throw in there as a test. So I hope that answers your question.
Okay. I guess I'm not sure that it does, but I guess my question is just kind of asking, why resort to modeling as opposed to just extrapolation in this case? Like normally modeling is used to test the strength of relationships. And the objective here, as far as I understand, is to forecast customers, not to test the relationship of various variables. So I'm kind of wondering why have the model in the first place and not just a extrapolation out.
So Ashton, do you mind if I jump in? So the way
go for it.
The way that I see this is what Ashton is doing is he's building a relationship between customers and population or employment, or even models like you had mentioned here. For 48 term wins this, so we don't include any population, we don't include any employment here. So this is purely an extrapolation of customer counts based on 48 terms. So what we do is we build a model, we give it multiple options, and then we test these options against each other, where we take the best option. So that's what Ashton mentioned is we have, let's say we test the correlation between population and customer count. Well, let's say that there's a strong relationship between population and customer count historically. But what we do is we take that Woods and Pool population forecast and we also incorporate that into our customer count forecast. So what it may, if we find out that 48 and population is our best forecast, what it'll do is it'll use that forecasted population and that forecasted, or the 48 terms, to produce a customer forecast.
Okay, that makes sense to me. Thank you. I appreciate that clarification. So going to slide 19. So I see that you guys are kind of, like you just said, you're kind of like ranking up all these different models for looking at things. And then going with the one that has the best AIC score. Does that mean that, I guess, is the implication of that then that you guys don't have a consistent model then for customer forecasting, but that you're essentially kind of throwing the spaghetti at the wall, so to speak, and choosing the model in each context that happens to work best?
Correct. Yeah. So we have a consistent model selection process, but the actual model will vary between all 200 different Citygate rate class combinations.
Okay. Does that, is there like an internal discussion about the ramifications of that?
I mean, we've definitely, I don't remember the specific, we've definitely roundtabled to figure out, come down, get this methodology. And we also have been doing, since the last IRP, like I had mentioned, some cross-validation to verify the results and against real world data. So I think that's kind of the first step that we've taken in, determining, is this the most reasonable methodology? But I'm definitely open to, to feedback if that's something that you have for us. But I'd say the first step we've been taking to verify this has been these cross validations. So I'll be doing that over the next few months or the next month or so, and presenting maybe a couple slides in the next tag.
Right. I guess like for me, it's just, I would feel kind of frustrating knowing that like you're doing all these different models and then fundamentally like there isn't a consistent, like, I guess, theory as to what's going on. It's more that there's just all these different models. That would just frustrate me personally. So I'm wondering if there is that kind of like internal conversation about trying to find some more like universal or consistent model to figure out what's going on.
I think I definitely feel you. I do get a little frustrated at that. I think I would be more inclined to line them all up if I was consistently seeing, say, 4A win. But sometimes, you know, population does win, or sometimes there's a really strong correlation for whatever reason at a certain city gate with employment. You know, sometimes there's just really strong correlations there that I just can't ignore. So I've kind of landed on, I just got to let it select what it thinks is best. But that's a really good point.
Yeah, it looks like we have 2 people with hands up. So I'll be quiet for a moment.
Abe, I'll let you go first since I saw your hand go up before mine.
Yeah, just following up on this particular point, and that's probably one of my confusions as well, is using different methodologies. I know the selection process is the same. I don't know the implications of, maybe this is a wider discussion of not having the same model for each type of study, but just for consistency, that when I'm looking at different, and to get everyone on the same page, you know, it's useful to have the same model. And if we do have the same model so that we know that this is the profile that happened from this IRP, for example, can you quantify the differences? Are they major? Are they minor when you're using different models? I mean, I could see the criteria, the AIC, is that what you base it on? But that's in numerical terms, but what does it mean in reality?
Yeah, so I obviously I don't have the numbers in front of me. I can tell you just from looking at it, if I were to show you the graph of those top 3 models, the Fourier, the population, and the employment plus Fourier, if I layered those on top of each other, you couldn't tell the difference between the lines. If I layered on, no, you would not be able to tell the difference.
Oh, okay.
Yeah, you would not be able to. You would probably be able to see a slight, if we zoomed in, you'd see a slight variation on those next 3 because they do score, 60 less. So you would see that differently. And then the ARIMA term, I could probably throw together a slide to show this by the next tag, or maybe just send it out to you guys individually.
Yeah, it would be great to see, but
just to see
what's the impact of all that visually? I mean, we can see differences on what's the impact of this on the bigger picture.
Yeah, that's a really good point. I would struggle to find the time to do it on the entire demand forecast because I would essentially be rerunning it
of
for
cour's
each
you're rerunning
model.
everything.
Yeah,
of course, yeah.
But I think I could
I
probably pull a few and maybe just give you an example.
I mean,
Maybe
your gut feeling about it more than actually doing it.
Yeah, my gut feeling would be you would see results within like a confidence interval that you might normally see. So they'd be close, not exact. With the one caveat to that, I would say, is on the employment and population model. If those are collinear, you're going to get really wild, wacky results, because when you try to regress on 2 things that are collinear, not always, but sometimes, like you might see this customer forecast go directly down to the ground. And I don't know why that happens, but so if they're collinear, you'll see really wacky results. But other than that, they all should be fairly similar.
But you said earlier during the presentation that doesn't always happen.
No, that's why it's very important to run the collinear test, because you can't just do it visually, which is how I thought you had to do it when I first started. I thought you could just visually tell, but I found out you can't. You actually do have to run the test for it.
So this seems to be a glitch in the software, or is it mathematically happening?
That's a good question.
I don't think it would be mathematically happening. I wouldn't
it
think
shouldn't be mathematically, so it might just be R.
Brian, can you jump to slide 7 for a second? I kind of want to talk a little bit qualitatively with regards to both of the questions that have been raised. I think it's important when looking at our system to really understand how disaggregated that we are. In talking about the different model types, philosophically, kind of the way I look at it is you have certain areas where there are different drivers to what's going to cause growth. So, Tri-Cities, for instance, where I and the rest of the resource planning team live, we are seeing significant population growth at this current time. I don't know if I would necessarily say that industry is following it, although there are certainly jobs in this area, but I don't know the numbers on top of my head, but I don't know necessarily if employment follows population in our area, while in some of our different areas, maybe Bend, for instance, and I'm just speaking kind of just very qualitatively at this point, so please bear with me on that. I know they have a major urban action plan going on where I know they're trying to get a lot of industry going to that town. So once again, off the cuff, I would imagine that employment, and Ashton's numbers may very well end up proving me wrong on this, but I would imagine employment is a much more significant driver of what we would see in growth versus population. So just with that kind of smaller example, and you're going to see different other microclimates throughout our entire service area. We serve some extremely small towns. We serve the Bellingham region. Which is a small town, obviously I'm talking for differentials. We serve Yakima, which is its own microclimate. We serve Walla Walla, which is its own microclimate. So with all of these different microclimates, and I mean socioeconomic and even political economic climates, with these smaller microclimates, I think that's one of the reasons why it's so important for us to do what Ashton does and identify for each specific microclimate what is the optimal model to run in that climate. So that personally, that's why I feel the technology or the method that Ashton's doing is very valid, because I think it accounts for a lot of those microclimate differences in the various regions that we serve.
Yeah, Devin, I just wanted to let you know that with respect to Bend, that the increase in population between the 2010 and the 2020 census was enough to significantly affect the redistricting in Oregon.
That's very good to know. And yeah, I know we probably have the numbers. We do have it with our Woods and Pool data, but so I guess once again, talking about an example, population may have been a big factor, but I also know, because I just ended up studying it when we were doing some of our growth drivers, that Bend, and you probably know more about it than I do, frankly, but they have their it's like their urban growth plan or their urban action plan, where they were really looking to expand the city, for lack of a better term, and really kind of push a lot of that industry in that area. And that was just one example, right, of how there's going to be differences as the relationship between employment and population and just time series variables. All of these are going to have different relationships in these different microclimates that we have.
Yeah, I was following the redistricting. I'm not that familiar with Bend otherwise, and I've been there once.
Gotcha. Abe looks like raised your hand.
Yeah, just following up from that. So if we accept that different models suit different city gates, that's, if we agree that this is a good way to go, because of what you said before, all the reasons, that's a good thing. But when I look at different IRPs, and I could see visually some differences, and I just wanted to know if you think that timing differences of a few months will change the selection ranking. Would that be a valid reason for seeing differences between IRPs? Because they are different in months.
I think it could, absolutely. I'm not going to rule that out, but I will say a major if you're talking about those graphs that show all the past IRP forecasts, if those differences are going to be majorly due to changing our methodology and evolving the forecast. So if you look at back in like 2016, that was before I was even part of Cascade. Was 2016 a combined IRP, Brian?
No, it was separate.
Oh, okay. So the 2016, I should have put either Oregon or Washington on that label. But that forecast was like before me, and that was done, much different throughout the years. And as we moved on, we added ARIMA, and then we added Fourier terms that, and we kept redesigning to hone in and checking the forecast results against real data. And so I think that, I mean, Brian, correct me if I'm wrong, but I would say that is the biggest driver for why you'll see those differences. It's not necessarily changing, demographics or anything like that. It's mostly just getting better at forecasting.
Yeah, so eventually that will settle down and you will find the best way. I
Exactly.
mean, eventually, but I'm talking about across between IRP of Washington and Oregon, for Oregon, for example. This is only a few months difference in data, probably. So I think we did see some of in your results. I don't know which slide it is that they do differ slightly, and I'm just a bit surprised that I could see some visual differences.
Well,
just between few months different, and is it because the methodologies changed between those, or is it just the data of a few months, the historical data that has been added to one of them as compared to the other?
Yeah, and I'll jump in real quick, and I can actually, so there's a number of reasons why. One is the timing. One could be methodology changes. One thing that happened between our 2020 Oregon IRP and our 2020 Washington IRP is we actually had a couple of customers switch from core to non-core. And so that's why you'll see, and I think they were in the range of 10 to 15 million therms annually.
Yeah, it was a big one.
Yeah. So if we have customers flip from core to non-core between two IRPs, that's why you'll see a big difference. And so what we have to do for each IRP is we just have to take the best information we can, put it into our models and run with it. And for the next IRP, there are a number of things that could change that will impact our forecasts. You can have customers change, you can have a methodology change, you can have more historical data that has changed compared to your old historical data. So all that kind of stuff can change. There's a number of things that can impact the difference.
Interesting. Thank you for that. Just the non-core to core to non-core, you said, does that mean that the demand has dramatically changed because they have gone elsewhere to get the gas?
Yeah, they basically, for the IRP in our upstream transportation modeling, we model for the core because the non-core does their own purchasing of upstream.
Yeah.
So yeah, that usage would transfer from our core usage where we have that forecast to the non-core forecast, and vice versa if they go the other direction.
So the volume will change quite significantly. Is that what you're saying?
Yeah, it could. Yep.
Yeah. Okay, thank you.
Mm-hmm.
Let's see. Could we return to slide 19?
Yes.
Yeah, I guess I'd kind of want to like empathize with like the frustration of just we're dealing with people and people don't do what numbers do.
Yeah.
Yeah.
Yeah. Let's see, next question. One thing I guess I wanted to highlight is that I looked at the slides ahead of time yesterday, and I'm like, that's a really, really linear like expectation for population in a population area for Bremerton. And so I Googled the population in Bremerton, and it's extremely non-linear if you go back to like the 90s. And so like, I'm not trying to say that your models are wrong or anything. I'm just saying that's just kind of like the frustration of dealing with people, is that the expectations, like reality isn't linear like that, and things don't always work out, the way that the model would suggest. Yeah, that's just a frustration with doing like econometrics and stuff.
Right. And I do want to reiterate and kind of just mention that Ashen his forecast is very similar to last IRP's forecast,
Mhm.
and it actually did a really good job of representing what we actually saw. So I did want to mention that, and I also wanted to just point out we do forecast out to 2050, but we do run a new IRP every 2 years. We try to run a new forecast every year for our internal finance and budgeting. So we're constantly updating these models and producing new models. So if there is any inaccuracy in 2035, we'll capture that in future IRPs.
Right. It's like tracking a hurricane.
Yep.
Yeah.
And I would keep in mind this is Cascade's customer forecast, not Bremerton
Yes.
population forecast. So
Right.
something to keep in mind. Again, it's people doing things. It's hard to predict people, but I think it would be strange if the historical is fairly linear, if that progressed or a relationship was really strong with the population, which you said wasn't linear, that would be super strange. But it looks like it didn't like that, and it's simply just extrapolated with Fourier terms. So it's tricky.
Yeah. It might be useful in terms to maybe put like expanding error bars as your data gets away from the present year.
Yeah,
Just to
those
kind
get
of
pretty
acknowledge.
big.
Yeah. So
Yeah, I
imagine
can do
the
that. I
line
can do
show,
that.
it's like turning on the TV and like the meteorologist like this is exactly where the hurricane is going to go, and there's just a line where maybe it should be more of a probability mapping.
Yeah,
I
oh,
really
yeah,
like your
I'll,
hurricane analogy.
No, I'm 100% sure this is what's going to happen. Trust me. No, I have confidence intervals I can turn on pretty easily, and yeah, I could show the uncertainty as it grows as you get farther and farther out.
Right, and that's what happened. That's what you were showing in the next slide, in slide 20.
Yep.
Yeah. Going on to slide 21. I noticed that when you're talking about these percentage customer growth rates, that they're all percentages. Percentage growth is non-linear. Is that just like a labeling error, or is this an averaging of percentages, or what's that?
Yeah, I should have labeled this. This is average annual growth for the rest of the planning horizon. It definitely fluctuates, year to year, but I just wanted to kind of give a generic average annual for the next, 28 years out to 2050.
Okay. So that means that we should expect then, if assuming the linear thing holds, we should expect a higher percentage growth next year and then a declining percentage growth till the end of the horizon.
Correct.
Okay.
Yep.
Going on to 22. So again, there's a intercept, kind of intercept/garbage term that I'd kind of want to highlight about whether that's actually supposed to be an intercept or whether it's just kind of put there, because a lot of times people, when they're doing these sorts of things, they just put the intercept term and they don't think about it. So I'm wondering if that has like theoretical significance or if it's just kind of a garbage term.
Yeah.
Yeah, I can. I have that on my notes to look into, because like you said, I didn't even think that would be something I need to look at. So no, I appreciate it.
We'll definitely take a look at those. I do think that in the use per customer forecast, the intercept does have more of a actual use, because there is base load. You'll notice in summer there's no weather that's going to increase usage. You won't see any of these other factors impacting demand, but you'll see usage, because there is a base load amount of gas that customers are going to use.
Mm-hmm. Right. So I mean,
Yeah.
an intercept term would make
We'll
a lot of
definitely
sense then.
look into it,
Yeah, I definitely think that because if you think about it, right, you have, not just space heating, but you have process heating. So people presumably may still want hot showers. People are going to use gas stoves for cooking. That's stuff that's going to be weather independent. I would imagine that's the stuff, or industrials, as Kathy had mentioned earlier, occasionally there are industrial customers that are producing 24/7. That's going to be captured more in that intercept than any of the variables. So I like your point on customer, I think that's something definitely worth exploring. But I think it definitely has a valid intercept in the UPC.
Right, right. And yeah, my point isn't so much to be critical, so much as just to make sure that like we're actively thinking about why things are where they are.
Yeah, super good point.
My next question is kind of about both about HDDs and price as they appear here. So with HDD, there's some pretty good data coming out of the Department of Energy that responses, or I guess how people respond to degrees for heating their houses, is non-homogeneous across the population. Have you guys looked into heterogeneous like modeling of how people respond to HDDs?
To some extent,
Brian,
yeah.
go
I can kind of kick it off, and then
Yeah,
others
okay,
can
go ahead.
feel free to chime in. One thing we haven't done as much granularity potentially as could be done on this, but one instance is a lot of the industry when I first started about 5 years ago was using 65 as a base temperature for HDD, and we kind of looked at our. It's so funny that you mentioned that. For the past every tag that we had this slide about where we started at 65 as our HDD baseline, and we switched to 60, doing some analysis of the heat responsiveness of our customer base. We switched it to 60 because of that. And finally, we were like, all right, we've said this every year. Everybody gets the point. We can cut this slide out. And it's a great question. I'm glad you brought up the question. And if anything, you take that question to a step further. With some of the other constraints that we're dealing with in terms of use of our resources, frankly, there's a lot of stuff with carbon compliance and various other things that we really need to focus on. So figuring out the kind of time benefit analysis of how granular we want to get on HDD responsiveness versus the benefit we'll get from doing that, I'm not sure where it'll fall, but we have at least explored it to some extent, which is why we shifted our baseline to 60 versus 65. As a more responsive number based on our population. It's probably not as perfect if we were to go down to the weather zone or city gate, but at least it's an incremental improvement. I think if time wasn't a barrier, I think it's a fantastic idea. I just don't know where that relationship lies.
Right. I guess the other thing, that reason why I would highlight the relationship is that when it comes to like customer outreach and stuff like that, knowing the spread of how your customers are reacting to it. So this is kind of like where the model forecasting meets what Monica does. At least as far as I understand what Monica does is like customer outreach and stakeholder engagement. So if you had a greater understanding of what that spread looked like, it might change the way that you guys interact with, or the degree to which you can factually or statistically corroborate what your stakeholder groups are saying to you. And it doesn't necessarily have to be that you model individual households. So there's a recent study that came out regarding COVID and how people spread it. And traditional COVID models are based on homogeneous assumptions about the population. And they found that they got extremely different results when they just did a very, basically a power rule applied to how they modeled people's susceptibility to COVID. So this isn't so much how it changes net customer forecast, but it might change how you guys validate or corroborate stakeholder feedback. So here's a link to the study. It's pretty interesting. So
yeah, I'd love to take a look at that.
With regards to price, and again, this kind of redundant to what I was saying about HDDs. My understanding is that a lot of things like this with like gasoline consumption, when you really only have like a single vector of consumption and you don't really have substitution, price, people don't really respond to price. That's more of like a neoclassical like ideology standpoint. Rather, it tends to be that people respond in terms of income. So regressing for income might be something that's more fruitful to you than price.
Oh, interesting. Yeah, if I can get the data on that, which I think we had talked about circling back with Monica. If I can get the data on that, that would be super interesting to pop in there and see if we get better coefficients.
Yeah, I was gonna say, I like that a lot.
Ashton, I think Woods and Poll data has income as well.
Oh, that's right. I forgot. Yeah.
I like that a lot because yeah, there's a lot of I've been actually recently looking into price elasticity of demand for some other stuff. And there's a lot. For one, it's in my opinion, from what I've seen, relatively inelastic, although it gets a lot more elastic at your lower income, which kind of speaks to your point. But on top of that, there's questions of, where is the responsiveness lie? As I talked about later, or earlier today, gas prices have gone up natural gas prices, not the gasoline people buy at the pump. Natural gas prices have gone up significantly in our area over the past couple of months. I don't think if I ask 100 people on the street, what's the price of gas at Sumas today? I don't think a single one could give you the answer unless I happen to find the one person that's in this industry. Because frankly, I would have no reason to know it either. But looking at responsiveness to, let's say, bills or even PGA filings could be a better indicator. But I really like income because doing income almost subsequently or indirectly captures the bill impacts. If you're on more of a budget, you're going to be a lot more cognizant of what your gas bill is and maybe make decisions based on that, versus if you are of a higher income bracket, you may have more of a luxury of just being able to set your thermostat at what you want it at and not thinking about it. So I like the idea of using income.
Yeah, it looks like we have a hand from Corey.
Yeah, I think that looking at the income responsiveness would be valuable. And I think what you're pointing to in terms of responsiveness to price is based on availability of information. I think people are far more aware of the status of their monthly budget, what's in their checking account on a daily basis, than they are about where their monthly gas bill is, because that's something they see once a month versus maybe weekly or daily.
Yeah, that's an excellent point. And I didn't even think about it, but then kind of taking it a step further, income could almost have, if in a world where gas prices were falling, people may not even see their bill, but if your income was low, you're probably going to be a lot more weather sensitive, even if the prices were falling, because you may not even look at your bill, but you have to be able to budget for certain things. That's really interesting. But yeah, I 100% agree that it is all about asymmetry of information. People just don't know, and why would they? Everybody's got, there's tons of industries that I don't know. I don't know what the price of crude oil is right now, even though I probably should. And I'm in the industry, so yeah, I think the asymmetry of information, but there is a lot more information about bills makes or people's income level makes a lot of sense.
And it might have to be something that we do where income is on only the residentials, because I know that industrial, some of those customers do follow price, and their coefficients were actually a lot higher. So maybe I could do income on just the residential and then leave price on commercial and industrial.
That's a good point.
Yeah, that makes a lot of sense. I guess going back, one of the things I always try to do as an economist is always go back to what are our theories about what's happening? And a lot of times when it comes to price versus income and people's responsiveness, you have to think of it kind of as a path dependency issue. So for example, with electrification, people talk about carbon taxes and stuff like that. But then you have to think about, well, who has the means to transition from gas to electric vehicles? And so income, or whether you're in the industry and you have millions of dollars to shift, really dictates your ability to respond to price. So it makes sense from a theoretical
it makes sense.
standpoint. Yeah. My next question is, what is the trend?
So trend is just if I start with a linear model, which again, like I said, in use per customer, I don't think it ever stops at linear model. It always wants more. If I stop at a linear model, then trend will help with any drifting that happens with the data. But like I said, trend is removed the second ARIMA is introduced, because ARIMA by nature differentiates the data, makes it stationary. You don't want to add in trend at that point.
Okay. So the next thing is people have been mentioning a lot of like these bans in like Bellingham and in Oregon for like natural gas hookups and stuff for new buildings. Are you guys aware of the Washington State Building Code Council decision that came out like 2 weeks ago?
Yes.
Okay. Yeah, that seems to be a pretty big shift. So I can't speak definitively as staff at UTC, but it seems pretty. There seems to be I would imagine that this should be accounted for in your final filing.
Yeah. Well, so here's the problem with that. This forecast has to be locked down soon. If there is a request for us to implement that adjustment into our forecast, we're going to have to do some end-use forecasting. So we have to work with our IT department, work with energy efficiency. We're going to have, that's like a 6 month to a year long project to adjust how our forecast is done.
Mm-hmm.
So we could shoot for providing a forecast, but all the avoided cost, the energy efficiency numbers that go into the IRP, those have to be based on a forecast that is produced and locked in very soon.
Okay, so maybe a narrative paragraph would be appropriate.
Yeah, that's what I'm thinking. Because of these building code changes, we're going to have to take a further look at end use effects. We didn't really have that in the past, so our models are just at the city gate level, at the customer level. Again, if we go into end use forecasting, we're going to have to roll some of this other stuff up. It's just going to be impossible for Ashton to forecast 1,000 different locations. So it's going to be a project within itself to implement this new change that we're seeing. And we'll definitely want to have more conversations. It's like you said, it was voted on 2 weeks ago, so it's very new to us still. Much of the analysis that you're seeing here today was done before that vote took place. So if we do want to implement that, I would suggest it's an action item, and we'll definitely include some narrative about it in the IRP.
Yeah, I mean, it'd be kind of unrealistic to imagine to have you guys completely, pivot on the spot and fix everything, just because something happened 2 weeks ago. But yeah, this is something I think we're going to see the ramifications, and they're going to be pretty big going forward.
Yep.
So I guess going on to the next page, on to 24, or is that two of them forward? Yes, 24. So what I see is that if I'm understanding your chart, this like data here that you guys are presenting in the chart, it seems like it's indicating that consumer use is going to be basically constant over the foreseeable future, like use per person. Is that right?
For
or use per
yeah,
customer?
yeah. For the use per customer for residential at Sumas City Gate, it looks like it's fairly flat for the planning horizon. Yeah.
Is that flat trajectory like basically uniform across all of the city gates, or is this a particular like outlier?
No, I would say this is fairly common for them. You will see, I could probably pull a few. There are some that are slowly declining. I don't think there's any that are actually where that cyclical nature is getting bigger. I'm pretty sure they're either flat or somewhat slowly declining.
Okay. Yeah, I was wondering about the flatness of it because I guess speaking from like, a 40,000 foot perspective, my understanding is that emissions per capita and emissions per GDP are going down. So it just seemed kind of odd that this one would be a flat line. It'd be interesting to see how all the other city gates compare.
So I will mention that this is before we implement any energy efficient measures. So this is purely based on historical usage. It does include historical like energy efficiency impacts to the usage. And so Ashton forecasts the use per customer, and then later on in the IRP process, we're going to decrement this UPC by what we're seeing from the energy efficiency groups.
Great. I appreciate that clarification.
Yeah.
Okay. Let's see. So going on to 25, where you show the impacts of the 4-year terms. I wonder about the 4-year things because like my understanding is that from kind of like a calculus standpoint, this is basically like a sinusoidal like adder that you're basically tacking onto the data. Is that roughly right?
Yep. It's a cosine sine combinations. Finds anything that's any sort of seasonality that can be attributed to like have a cyclical nature, I guess is how I'd say it.
Okay. Is it possible that this is a pretty big difference that your 4-year term is adding. Is it possible that there's a gap in your data that's not being accounted for? Because it seems weird that people would be like, oh, I'm just going to consume differently simply because of the time of year. Like, do people respond differently in the fall to an HDD compared to the same HDD in the spring?
So I would say that go for what were you guys say, Brian?
I was going to say that we have noticed a difference between an HDD at different time periods. If I can find this, whoops, sorry. If you look at these results right here, you can see an April HDD is 0.009 or a May HDD is 0.006. So there is a slight difference between where the HDD is taking place and the result. It's not huge, but there is a slight difference.
Oh, that's not just slight, that's like double. That's more than double between like September and like February.
Yeah, so the summer and shoulder months, I believe we left them in there, even though, and Ashton will have to remind me if there's statistical significance on them.
Yeah, so we used to do almost stepwise regression where we would look at it, we would measure their significance, and if they were deemed not significant, we would take them out. But reading through some academic literature and stuff a few years back, stepwise regression is getting a lot of, for lack of a better term, hate, and a lot of the econometric models are starting to leave those in, even if the model says they're not significant. You leave those in as a predictor, and I played around with that, and the graphs do look different. So we went ahead and just stopped doing stepwise regression where we remove insignificant quote unquote variables, and we left them in there and call them econometric variables.
Yeah, and also just point out that we don't have very many HDDs in our May through September time frame. Most of that is usually around base load. So part of that may just be that people aren't turning on their or different customers turn on their meet their thermostats differently throughout that area. We just don't have very many HDDs in May through September, so it's a little tough to get a representative. But that's basically that's why we break out our HDDs by month, because we do notice a slight change.
Yeah, that seems like a kind of almost like non-linear response to HDDs.
Right.
Which makes sense because heat loss is non-linear.
Yep.
So I was just kind of highlighting that in case, like, it seems like there might be some data loss or like modeling loss that the Fourier is basically cleaning up or picking up. And so it might, I'm not sure how much, if it's actually worth the time, but coming up with what factors or like data it would take to get rid of the need for Fourier might be interesting in terms of, I guess, like from a more theoretical standpoint of making your models more robust.
Right.
So going on to 26. I think you guys kind of addressed this later, but I noticed that there isn't really a trend on your peak forecast, but you talked about that later under climate. So it'd be interesting to see how those modelings get married, how that modeling gets married together. But I think it sounds like you guys are already in the process of doing that. Is that right?
Yeah, we just wanted to pull the stakeholders for the climate change impacts, and once we land on one, we can then redo this peak forecast with those assumptions in it. Yeah.
Okay, great. Let's see. Try to figure out here. Okay, so let's see. I'm just looking through my comments here to make sure you guys got everything. Oh, so next is slide 33. So looking at the historical data here, the historical data seems fairly volatile to me.
Yeah.
In fact, the volatility of the historical data seems like it could basically eat up all of your modeling, if that makes sense. Like all of your the variability between your models seems to fit within the volatility of the historical data.
Yep.
I think in terms of modeling future demand, it might be useful to put error bars around your models. So kind of like we were talking about earlier, increasing into the future, increasing like indeterminacy. Because I just like you said earlier, you don't think the green line is exactly what's going to happen. So it makes sense to me if you're looking into the future, trying to protect against volatility, having an estimate of what that demand volatility would look like would be useful.
Yep. Yeah, and we'll definitely do some Monte Carlo modeling around usage and weather patterns. We'll put that into our Plexus modeling.
Hey, Brian, real quick, and Ashton, you may also, for that historical, is that weather normalized or weather actuals?
It's weather actuals.
That's actuals. I just pulled it from a sales report. So that's why you see like 2019 was like super cold and fall 18 was like way warmer. So
that's going to be another reason. So beyond just the very present error that can be ingrained in any forecast, the forecasted lines use weather normals, which are always nice and smooth and assumes that weather acts exactly as we expect it to, while normals, as we are encountering in our trying to figure out what we're going to do for the carbon compliance stuff, weather hardly ever acts exactly as you expect it and hope it to. So that kind of, but I agree the error terms are valuable, but I think that's also potentially helped explains a lot of the volatility in the historical versus forecasted.
Mm-hmm.
Yeah.
Can I jump in? So if we do look at volatility, and probably will make the graph harder to read, what's the impact on really the planning process? If we do include it or not include it, at the end of the day, looking at the end result, or the end product, final product, which is the planning process, will it make much difference?
Do you mean the volatility around the econometric model, or maybe around
what
weather?
we're looking at now, like the Washington demand and all this, will it make a difference in the planning process?
So
I mean, and when you're going and doing investments, and it could be operationally, it could have an impact, but for investments and for the planning process itself, will it make a difference?
So there's definitely some areas where it makes a difference. When we're talking about upstream transportation and distribution plans, we're looking at one single day. So that's where peak day is really important. As long as we can meet our peak loads, we can also meet our annual loads. In terms of some of that modeling. Now, decarbonization modeling may be another story. If we have several cold years in a row, we may have some emission targets that or emissions that are higher than we expected. So there's definitely some concern around that. We'll need to discuss those kind of scenarios with the CPP group and the CCA group, and just make sure we know what happens in those cases. But yeah, there's some aspects that planning does change based on extreme volatility, and then there's some aspects where you kind of have to pick like a peak day and model off of it and use it as deterministic.
I'll just add on to what Brian's saying real quickly also. As a little bit of a teaser to some of when we get into the stochastic analyses, in a lot of our IRP process, the philosophy we've taken is usually to do risk-adjusted metrics for a lot of things we do. So deterministic results like this will usually carry around 75% weight, while stochastic results will usually carry around 25% weight. And so that allows us to, in that planning process, and obviously that's not an exact science, but in our planning process, it allows us to have some impact for that stochastic potential while still heavily weighting our decision based on what we deterministically expect to happen. So in some ways, that's kind of how we inelegantly, for lack of a better term, try to account for some of that variance in our planning processes.
Yeah, just thank you for that explanation, because I come from the electricity industry, and when you look at, I mean, from places like Australia, where I come from, you can look at the state and you can see the peaks that are way higher than normal. Like the normal is only 55% of the peak, and the peak is only about 8 trading intervals or 4 hours in the year. It does not make sense to build poles and wires for only 4 hours. So you look at things like demand response and all this. So that's what my thinking is, that the high demand days is not necessarily a reason for changing the planning process too much.
Yeah, absolutely. One thing I will say, sorry, just to jump in real quick, because I did just have a thought, and we addressed this a little bit in tag 1. One difference that we have to be cognizant of in the gas versus kind of the electric world is, to some extent, I guess, to put it bluntly, the stakes are a little bit higher. In the gas world, in the electric world, obviously, while nobody ideally plans for things like brownouts, blackouts, rolling blackouts, it's an acceptable potential outcome, not an ideal one, and certainly not rooted for one, but it's something that happens. I grew up in New York. We had a big blackout in I think it was 96 or 97, and it was crazy, but it's something that happens in the world. if we have a significant failure on the gas side, it's fairly catastrophic, besides the impacts that Brian talked about in tag 1, where, oftentimes there is the issue of relighting pilot lights, which can be very difficult. Gas is also oftentimes a heating source. When we talk about planning, one thing we always talk about is we want to make sure that grandma and grandpa can keep their houses when it gets really cold. And that's a real concern for us. I think, not that there aren't concerns on the electric side. I do think the stakes are a little bit higher on the gas side, though, and I think that's why we do plan so heavily for those peaks, however improbable they might be.
I agree with you. I mean, we had a blackout in 2016 as well, but a lot of electricity experts would say, having one every 10 years is not a big deal. I mean, considering the restart of the system takes 2, 3, 4 hours or maybe a day. I do remember that when I was living in Wellington in New Zealand, we had the water and gas get mixed up in the pipes in the distribution system, and it took weeks. Yeah, it took weeks to get back to normal for everybody. Wow. I mean, people varied and they're coming back. And I remember friends have to come and have showers at our place because we had, I think we might have had electricity at that time in that place where we lived. And yeah, it is a much harder, I guess, thing thermodynamically, I guess, because of the heating up and pilot lights and and all the startup issues that comes with gas compared to electricity, which is almost immediate, depending on the source, of course, of generation. But yeah, I agree with you totally. It's a more crucial for gas.
Absolutely.
Okay, I wanted to mention we have hit an hour for questions. I just wanted to touch base, Byron. How much longer do you anticipate we'll need for more questions?
I have about 3 more questions left. So if we can jump through them pretty quickly, they should be pretty straightforward, I think.
Okay. Yeah, let's do it.
Okay. So skipping to slide 37.
Yep.
So this one was about basically you guys were asking for stakeholder feedback about which kind of like climate models to use.
Yeah, so these climate change models, they'll impact our normals, and normals are what we use for our weather to forecast for our forecast portion of each sheet.
How would you want stakeholders to get feedback to you? What would you want that to look like?
So you can give me a call, you can send us an email, I'll probably, however you give us feedback, I'll probably put it in our feedback report.
Okay.
So any of those ways works.
And I guess, is there any more information you could give us about where these models come from, or is it just that you want us to follow up on those hyperlinks at the bottom?
Yeah, I think if you follow up on these hyperlinks, you should be able to find the data. If you can't find the data, let me know, and I'll work with you to show you what we did.
Okay. Jumping next to 45.
Yep.
So you guys mentioned basically that the EIA says that there's like a significant decrease in demand, but you guys didn't pick up on anything. What's the kind of takeaway for us from that? Because it seems like it's a little bit contradictory, but also you guys are just like, there's this big national trend, but it didn't affect us. Is that just the kind of the takeaway from that?
Yeah, so we just like to present just some of the data that we're looking at. It's important for us to both evaluate national and regional trends. And I think kind of the big takeaway that at least I thought when we were composing that is that since our region definitely, especially compared to the rest of the country, it has its own unique challenges and aspirations. that we're going towards, that it is important to look at certain national trends, but we also do need to keep in mind that we are in some ways segregated from the rest of the country on certain impacts.
Yeah, and I also wanted to point out, Devin, correct me if I'm wrong, but this is all geological natural gas, right?
Correct.
And so I'm guessing that usage is still going up, but we're seeing more RNG and hydrogen being a part of that supply as well.
Yeah, I would say it's not necessarily, because we're talking billions of cubic feet.
Yeah.
We're not in the region anywhere close to billions of cubic feet yet.
Correct.
But that's a good point. I do think we are looking at this side of the country. Eventually, as you start to see some of these reports coming out about geologic natural gas versus other sources such as hydrogen even, and renewable natural gas, that may cause for a little bit more of a disparate treatment.
Okay. And I guess my next and last question was on those lines, is basically, how does renewable gas, RNG, and hydrogen impact your long range price forecast?
So that's a great question. The price forecast that we run, that we've talked about in this slide, or in this kind of sub presentation, is specifically our geologic natural gas price forecast. So it is one tool that is used kind of as a plug and play in varying other tools, such as our Plexus optimization modeling, such as in our hedging modeling. So the forecast we're talking here really is only about the geologic gas. Where the other stuff comes into play is in certain resource acquisition decisions, I guess I would say, where when we put it into the giant sausage maker known as Plexos and try to crank out what the decisions will be, this gives one side of the coin, or one facet of the die, that the model can choose from, with the pros and cons from its perspective of geologic gas has cost X, but emissions Y, versus renewable natural gas has cost A with emissions 0 or whatever, right? And so the whole purpose of this is essentially, really, I guess, in relative to RNG, to create the counterweight for which those resources can then be compared against.
Okay. Would it be appropriate to assume that you guys would elaborate on that more at the next tag when you guys talk about alternative resources?
I believe that would certainly, yeah. Is that when we talk about Plexus modeling, or is that tag 4, Brian?
It may be tag 3 or tag 4. It's one of those.
I definitely think we'll introduce the topic when we start talking about RNG as a resource, but I think we'll really start to drive it home when we talk holistically about Plexos modeling and that interrelationship between RNG and conventional or fossil gas versus the emissions that each one has, and how modeling tries to accomplish finding that marriage between the two.
Mm-hmm. All right, that's all the questions I have. So thank you guys. Thank you guys for taking out the extra, I guess, 48 minutes to hear all my pedantic questions.
No, personally, I think your feedback was invaluable. I really appreciate it. Like, thank you for taking such a detailed look at our presentation and coming with excellent questions. I really appreciated it.
Yeah, I mean, it's most of the time people are snoring through some of this stuff. So it's nice that someone was actually listening. I wasn't talking to a wall.
Yeah, thank you. I was reluctant to ask some of your questions, actually. I didn't understand, but you encouraged me to ask some questions. Thank you.
You can always ask us questions. This has been a great conversation. This entire tag, I think we've learned some new approaches to consider and to look into. This give and take of this session outside of the tag has been real quality. I think it's gonna help us produce a better product. I have a question though, Brian.
Yes.
Are we still recording this?
It is still being recorded. Yes.
Excellent. Excellent. I just wanted to make sure so we're capturing all of this.
Yep. No, I'll keep it recording until we end the meeting. So if anyone wants to go back and rewatch 4 hours of tag meeting, feel free to do so.
I'm bored. I'll do it.
Hey, Brian, this is Bruce Folsom. Would you repeat your invitation to hold workshops or one-offs in the future as much as people would like?
Yeah, definitely. If there are any other questions or workshops or anything like that, we are open to do so. We try and cover as much of this information inside the IRP. That way it's recorded, as many people can make it there. But if there's follow-up questions, feel free to reach out to us and we'll set something up.
Thank you. Yeah, this is not a one and done.
Correct. Yeah. All right. So if there are no other questions, we'll end the meeting. Any last comments? Any thoughts? Questions? All right. Sounds good. Thanks, everyone. We'll be in touch.
Yep. Thanks, everybody.
Great meeting. Thank you.
Thanks a lot, everyone.
Thank you.
Thank you.
Thank you.
Thank you.